Hi, can you hear me? Hello.
Hello. Hello.
Hi. Hi.
Hello, how are you?
Can you hear me?
Yes, we can hear you. Can you hear us?
Yes.
Okay, that's good. Would you like to test anything?
Yes, please.
Okay, would you like to maybe share a screen or something? A video.
Yeah, we share the screen.
Allow you now. Okay, I've allowed you.
Okay. Hello.
Hello.
Hi.
Hello.
Hello.
This is Laura. Hello.
Hello. I've changed my Wi-Fi and I think that now it's working better.
This is working better. We can see it on our side. It looks good.
Okay, I'm going to share again.
Okay, share again.
Yeah. And
You can go to your full. Okay, there you go.
okay. And this is presentation mode.
Yes.
And now I am going through the slides. Can
Yes.
you hear me and see the slides correctly?
Yes, we can. Yeah, the slides are following you.
Okay, perfect.
Okay, thank you.
Thank you so much.
Pleasure.
So I'm going to stop sharing. And this is it, right?
Yeah. two, two. One moderator. Moderator. I'm Mr. J.
What's going on there?
Are you the moderator for this session? Or you the moderator? So which moderator? Yeah, yeah. So are you gonna sit down or you gonna be? Oh, I'm gonna use for Q&A. This will be used for Q&A. Or maybe if the speaker wants to use this one, I'll leave this one on the yeah.
So how do you use it?
It's
Do
on
you have
mute.
to press?
No, nothing. Because I blocked it, so it's on mute. Don't have to do nothing to yeah,
Unmute it when you speak. Okay.
Yes. Any other speaker wants to use this, you can keep this. This one is gonna be for Q&A.
Okay.
So I very much love to see people networking, but if it's all right with you all, I'd like to start. So my name is Connie Walker, and I am a scientist at what they call NSF Noir Labs. It's actually like a observatory, a national observatory in the US. And I'm also actually the co-director of a satellite sort of interference organization we have called CPS. So we're looking at satellite interference on the impact on astronomy. But this particular session is solely on ground-based light pollution and radio interference. And that's where we're going to be focusing. And we have so many great talks and so many great posters that I hope you'll go see them or at 3 p.m. now. We had some up at 10 a.m. And what I'd like to actually focus on right now is the fact that we are so grateful for all you've done for the field. And we're grateful for the things you will be doing, especially after networking with so many wonderful people here and getting new ideas from the talks and from talking with other people. We're at a sort of, I would say, a crossroads where we can actually take a huge step forward in many, many ways. More people all over the world and more organizations all over the world are seeing the importance of preserving our dark sky, not just for research, but also to preserve our cultural heritage and so many other things. So with that, I'd like to go to the next slide, please. And I'd like, actually, is Ruskin here right now? Ruskin, please come. Ruskin is the executive director of what they now call Dark Sky International, and it was IDA when this co-founder, one of two people, was actually very, 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 very influential. He left a huge legacy in IDA, which is now Dark Sky International. And I'd like Ruskin to say a few words, please.
Well, thank you, Connie. It's an honor to be able to share this. And I'm a little embarrassed to do this because I joined Dark Sky 5 years ago, and I actually never met Dave Crawford in person, unlike people like Connie and John, and no doubt John Hernshaw and others who worked with him very closely. Now Dave was a professional astronomer. He worked at Kitt Peak. He actually, I think, helped develop some of those major telescopes. And an amateur astronomer by the name of Tim Hunter approached him. Tim Hunter was a physician in the town of Tucson, and he noticed that they were changing out some of the lights on their local hospital. And Tim understood that was going to impair his ability to do his passion, which is amateur astronomy. So he approached Dave Crawford up on Kitt Peak and said, "We have to do something about this." And they rose to that challenge. They said, like, if not us, who's going to do something? And as Tim told us, they decided they would call it the International Dark Sky Association, because if they called it the Dark Sky Association, the acronym would have been DAR. And they didn't like that for whatever reason. So they set up the International Dark Sky Association, and it quickly grew into its name to become an international organization really focused on bringing this issue to the fore. One of the things Dave is known for is actually reaching out beyond the astronomy community. Tim has and others have shared with me, Dave Crawford didn't spend much time at IAU meetings or American Astronomical Society meetings. He spent time talking with the lighting engineers and the lighting community, educating them about the impact of the work that they were doing, and in fact founded the lighting committee, outdoor lighting committee, the Illuminating Engineering Society, which is going strong today. His mantra, which I think should be the mantra for all of us, is really, we need to make friends, not enemies in this. We don't need to demonize people about the decisions they're making about lighting, because most people are making them because they don't understand the impact that is having either on a professional telescope or an amateur telescope, or more and more, as we'll talk about today, on wildlife and ecology, on culture, and even on human health. And really, that was the mantra that he brings, and that's the mantra that continues to guide Dark Sky's work. And it's wonderful to see so many friends here joining IAU. And I get to come to an IAU meeting because I am not an astronomer. So I want to reach outside my communities and engage with the professional astronomer community, and I'm excited to spend a day with you all here today. Thank you, Connie.
Thank you. So to summarize, we are having this session this whole day in memory of Dr. Crawford. So, okay, so with that, I'd like to also introduce our two co-chairs, along with myself, is Ramatholo Safako and James Lowenthal, and they're going to make themselves known in just a few minutes, some more. Okay, next slide. And just to say a few things, we always want to respect the code of conduct that IAU has formed and respect each other. And I don't think I need to say more. We have 5 oral presentations coming in the next few minutes. They're going to be 8 minutes plus 2 for questions and answers. And we're going to have then a 20-minute, hopefully 20-minute discussion. And then we have a series of lightning talks this morning, about 2 minutes apiece, that are on the posters that you see downstairs. And that'll go until 12:30. We were actually granted some more time, and it may or may not happen because we have a couple of posters that are missing, but that we'll see. But the session chairs will be very strict about timing, so I hope you don't mind. And then presenters, we're asking you to be as close as I am to the mic, and at home too, if you're presenting online. And then to always say next slide. And the people over there, the wonderful people over there, we should clap for, because they do such a great job. They will be advancing the slides. And to ask questions, we want to do this in the Zoom chat if you're online, or you can raise your hand online as well, or in person. And we have a mic available. We'll be traveling around with a mic. And then every day, you can also stay in touch with our Slack channel. And actually, we have a beautiful website that we forgot to put up here too, that we had developed, where you can actually see easily the abstracts that go along with each of the talks. And we're going to also, with the author's permission, put in the presentations as well. So you'll have some place to go to for a record of what we've actually talked about today. Okay, with that, we have the next slide. And now we're going to go, as I've told the tech team over here, into 5 talks. And they're going to switch to the first talk now, if you would. Thank you. Ramathala, would you take over? Yeah. Thank you. Thank you, everybody.
Okay. All right. Thank you very much. Yeah, so I'm going to be taking over now, and James Lowenthal from Smith College will be giving his talk on WES plus IAU equal tax rise.
Thank you, Ramatolo. And sorry, can I confirm, Shanique, am I able to advance myself? Okay, good, thank you. What a privilege it is to be here in Cape Town on the continent where people first looked at the stars. I saw the Southern Cross last night for the first time in 10 years. The huge environmental cost of my long travel to get here, all of ours, most of ours, is, in my mind at least, justified, at least partly, by the urgency of our collective imperative to protect and reclaim natural darkness at night for all people, including astronomers, and for all life on Earth. I'm here representing the American Astronomical Society's Committee for the Protection of Astronomy and the Space Environment. The AAS membership itself, the AAS, includes most professional astronomers in the US, as well as amateur astronomers and students. There are about 8,000 members of the AAS currently. An overview of the committee that I'm representing here, which we call COMPAS. It goes back quite a few decades, and there should be a movie playing. This is a PDF, and is there a way to start a movie without advancing the slide, Shanique? That advances the slide. Okay, that's all right. It's an embedded movie, which we'll skip right now. The committee has been around for decades, but in its current form only since 2019. Or actually more recently than that, but I'll say it was rebooted in 2019. That year, many of you will recognize as the year Starlink first launched. And the movie that I was planning to show was one of my personal experiences with Starlink, and I'm sure you have all had them as well. I was on vacation in Maine in 2021 with my family. The state of Maine has some of the darkest skies in the eastern part of the United States. And I was very much looking forward to the experience of bathing in the light of the Milky Way for the first time in a long time. And I did that. We had beautiful, clear skies. And I was out there on the beach at midnight, and everywhere I looked was a satellite. And it was impossible to get away from them. And it affected me deeply in a way that I know you have all shared. That was in 2021. When the number of satellites had already been doubled in just 2 years, more than doubled. Since then, it's more than doubled again. And obviously, it's only getting worse quickly. So the current form of this committee, it was rebooted, prompted by the dramatic rise in the number of satellites, but it has also reinvigorated our efforts at protecting the night sky from ground-based light pollution. So you see here the charge of COMPAS officially. You've probably had a chance to read it. I won't dwell on it further. To put a little bit more detail on the shape of our committee, we have organized ourselves into these 6 subcommittees. And I'm very happy to say that it's a tremendous group of people. And all 6 of these subcommittees represent a great depth of expertise and experience. Some are more active than others, and this may change, but we feel that these 6 subcommittees cover the breadth of our charge effectively. I welcome you to come to our beautiful new website. Thank you, John Barentine and Jessica Heim, who are here, for putting together this website that has a great deal of information, resources, guides to our current activities, and resources for non-experts in this field as well. And the QR code here will bring you to that website if you're interested. Who is the committee? Here are the 34-ish members, including 8 folks who are here at the IAU meeting. So we have a pretty healthy contingent. We are ably led by the expert and wonderful Tesni Pugh and Aparna Venkatesan. Aparna, just raise your hand here if you would, please. You'll see I've pointed out here that this committee membership includes experts from the National Science Foundation's Noir Lab, where Connie is, from the National Radio Astronomy Observatory, from the American Association for the Advancement of Science. We have congressional staffers on the committee. We have Ruskin from Dark Sky. Many of us are also associated with Dark Sky, but we have the executive director working with us directly. Major US observatories, apart from the national observatories, are represented. And we have experts who are non-astronomers, but are expert in space law, helping advise us and advocate for protection of the night sky at the highest levels of national and international government. I'll just briefly highlight a few of the most recent, most prominent efforts of our committee. We have been very active at AAS meetings, and most notably at the most recent AAS meeting in June, we were featured by our stalwart co-chairs, Aparna and Tesni, in a plenary talk before the several thousand gathered astronomers there about dark and quiet skies, about the imperative to protect them, and about the magnitude of the threats we face. We also hold at the meetings regular meet and greet sessions where we network. We have special sessions on SatCons. We had experts from the city of Flagstaff, the world's first dark sky city. Some more highlights. We have over a dozen statements in the work, including a letter we've written to the Department of Energy pointing out that their policy of promoting LEDs has led to more light, not less energy use. We have endorsed the ESA Zero Debris Charter and numerous others. We have produced leave-behinds. You see the 3 at the bottom there for anybody visiting their congressional representative. We leave a piece of paper with them, and there are copies in the back. Campus Shine is a how-to kit for anybody on any campus, how to start light pollution fighting, how to turn back the tide of light pollution on your campus for anybody who doesn't know how to start that, including a slide deck we have that could be shared in anybody's college class, not just astronomy, could be ecological conservation or built environment. We have briefed the Department of Defense, the State Department, the Department of Commerce, the National Academies of Science, Congress, the White House Science Office, Space Force, and we continue to schedule additional briefings about the magnitude of the challenges we face to protecting dark skies. And of course, we collaborate with Dark Sky International. We also helped organize the SatCon 1 and 2 meetings, and you see the poster for it there. I'm happy to say that just last week, a bill was filed in the US Senate called the Dark and Quiet Skies Act, which would devote upwards of $10 million over the next several years to form a new center of excellence on SatCon interference. This has a long way to get to be signed into law. It's just the filing of the bill, but it's a major first step. And I'm happy to say this was written by our Compass co-member, Lindsay DeMarchi. There is lots of opportunity, and I'm getting to the end here, for synergy between our national organization and the IAU. We already have a lot of overlap. For example, Richard Green, Connie Walker, John Barentine, Jessica Heim, as I mentioned, we're in both organizations working in dark skies. We were, many of us, very active in Dark and Quiet Skies 1 and 2, which was an IAU series of conferences about SatCons. We overlap through the Executive Committee Working Group and Commission B7, which we invite all of you to join. And we have mutual support between the AAS and the IAU for numerous statements, such as on SatCons and on space debris. And I will just close by pointing out that this fellow appears to be alone as he stands contemplating the Milky Way and the cosmos. But he's standing on the footsteps of thousands of generations before him. He's connecting to the sky, and he's connecting to culture and society and humanity. the main benefit I see in gathering us all here these 2 weeks is indeed the social aspect, the networking, the building of community. We are building a social movement, and our critical imperative is to build that social movement internationally. And as Ruskin quoted Dave Crawford saying, to make friends, not enemies. Thank you.
Quick questions for. Yep.
Actually, can you bring in the mic?
John Hernshaw, in case you don't know me. Those 6 subcommittees I think are very important, but I would say the most urgent case is for community engagement. So that subcommittee must play a very important role, because the whole issue of light pollution, ground-based artificial light at night, is a matter of convincing communities that this is important. And people just do not realize that, especially politicians. And they are the ones that control the lighting.
Thank you, John. We do have a lot of communication with politicians outside of community engagement, but it is true that community engagement, as we have conceived it, includes everybody who's not an astronomer or who's not a professional astronomer. It includes amateur astronomy and astrophotographers and astrotourism, and it includes indigenous voices, and it includes the average person in the world who wants to look at the stars unimpeded by light pollution. So it is an enormous charge, and we take it seriously, but I take your point that maybe we should expand that mission. Thank you.
Okay, thanks. Any other question? And online, is there any questions online? No. Okay.
Aparna had a hand up.
Oh, sorry. This is just a comment. Hi.
I think we could hear you.
Okay. There's lots of buttons in the back with our brand new logo, with thanks to our community engagement group led by John and Jessica. And also, was it Brackney who did the design of the Brackney Pickett, the design of the logo? So we have buttons, but also copies of the 2-pagers that James put up for you to take back into the Zoom, folks. Sorry, we can't hand that to you, but please find us at a future conference. And also, with 8 of us here, please find us if you'd like to support our efforts or join us in any way. Thank you.
Thanks for reminding us of that, Aparna.
Okay.
Check out the material in the back.
Thank you. Is there any questions online? No. Okay. Last question here.
Just you have created such a rich portfolio of resources. Do they travel well outside of the US? Are you prepared to share it? Can they be customized?
It's all on the internet. There's no firewall. Please take everything we have and use it in your own way. I see no reason not to
Sure.
grab anything you can find, and we're certainly not holding it.
And we can
locked up.
customize it as required.
Of course, yes.
Okay.
And we should communicate about any details, any questions you have, but the
Thank
general
you.
answer is yes, please.
Thank you.
Okay, thank you.
Thank you very much.
Let's thank John again. Going for John. Next one. Okay, so the next speaker would be Carol Nyaguti.
Hello, good morning. Can you hear me?
Yes, we can hear you.
Okay, I'll share my slides now.
Right, great, thanks.
Please confirm if you can see them.
Yeah, I can see them.
Great. Okay, so good morning. My name is Carol Nyaguti from Dark Sky, Kenya. Pleased to be here today to present on the work of Dark Sky Kenya in Dark Sky Preservation Initiative in Kenya. So today I'll be talking about Dark Sky Kenya and what dark sky advocacy looks like in the Kenyan context. I'll also talk about raising awareness and educating people through engagement. I'll also talk about on advocating for proper urban planning. I'll also talk about our goal to influence policy and also protecting the existing dark sky places. Okay, so about Dark Sky Kenya. Dark Sky Kenya was the first chapter of Dark Sky in Africa. It started last year in February, and so we are relatively young, and we currently have 60 registered members, and these are just a few of our members in some of our meetings, our in-person meetings. We have in-person meetings and online meetings sometimes. And so Dark Sky advocacy in the Kenyan context. So in Kenya, unlike some developed places, we don't have a lot of electrification in around the country. So most electrification is around cities and urban places. So that means that we have a lot of dark skies. And so the thing that's happening is that we have a lot of now electrification that's happening. And so without any awareness about light pollution, and there's the correlation about safety and lighting. So what's happening is we have these security lights that are being installed. We call them mulika mwizi here, literally translating to shine light on the thief. So they are very bright, and as a result of this, what we see is as this continues, we'll continue to lose our skies. So our work right now is to create awareness. So we don't have much of our skies disappear, our dark skies disappear with electrification. So as I've mentioned, we have a lot of dark skies, and Kenya is known for astrotourism. For tourism. The tourism sector in Kenya is big, and so most of these nature reserve tourism reserves, they are already dark places, and we also have communities that border them. These mostly the Maasai community or these communities that keep livestock, and we also have the human-wildlife conflict. So one of the things that happen is the lions and the cheetahs and these wild animals come and attack these animals and eat these animals belonging to these communities. So what has happened? One of the solutions that has been brought about is these lion lights. These are lights that are put in these compounds in the cow sheds, around the cow sheds, just to scare off the wildlife. But what happens with the increase of this, we see that with the increase of this, what will happen is there'll be introduction of a lot of light pollution in these places that are already dark. It will introduce a lot of unwanted light or light pollution in these dark places or in these tourism reserves, which will affect also the wildlife and the nighttime ecosystem. So we're looking for ways to ensure that there is safety for these communities living there, but also that the solutions that will be implemented do not affect the already existing dark places. And so what we are also doing is raising awareness through engagement. So this is through citizen science and measurements. So most of the measurements we have about light pollution levels here is from satellite data, but we want to have ground measurements. The thing Dark Sky Kenya has done is to partner with Astro Sentinel. This is a application. This is a platform for mapping light pollution levels specifically in Kenya that was developed by myself. And so we want to encourage more people to come together and just collect these measurements, just to get people. We see that by engaging people in collection of these measurements, we'll be able to first not only just get data and just get more insights into how light pollution is happening or how it's manifesting on the ground, but also to get people interested in how it's manifesting, and also in coming up with the solutions, because now as they engage, they get this understanding of what it is even more. I'll discuss more on the measurement later. So we also advocating on proper urban planning. And so earlier in the year, we partnered with Deloitte, and they shared with us the daylight fixture, which is a local solution that's sky friendly fixture. And in these images, you can see one of our members holding one of the fixtures. So it's just we used upcycled bottles. So this black one you can see is basically a shampoo bottle. So it's low cost, and then we were able to assemble them just to check out how effective they were. So some in this image, I believe you can see we have a few of them, and we had ideally we should use a black bottle, as you can see here, and we are at the bottom. We were testing it inside a dark place, which was inside the planetarium, the Nairobi Planetarium. We can see we have just the light going down. So yeah. And some of these, you can see there's some, we also tried with the white bottles just to see how that will happen. And also another white bottle, which we also had aluminum foil also outside, and you can see there isn't much glare from it. And so with this, we're able to see how that works and how effective it can be. And so in the next project, we want to do a pilot project in a certain location and see how effective having this retrofit, how effective it will be in cutting out a lot of light pollution in the area. And also one of the things we're also looking forward to doing very soon is outreach to urban planners. At the moment in Kenya, we are at a special, like we have these unique advantages in that, given that we don't have a lot of electrification and development is still going on, we have this unique advantage that we can influence how this goes forward. So we want to engage the urban planners and the lighting industry so that going forward, they are able to implement the dark sky friendly lighting. Yes, so yeah, we can influence how that goes on going forward. And so on influencing policy with the measurements that we collect in the citizen science, we want to understand how the light pollution issue manifests on the ground. And so we've also been in communication with the Kenya Space Agency, and they're very much interested in supporting the citizen science project. And also they are also very interested in partnering or collaborating with Dark Sky Kenya for the Dark Sky Kenya activities in outreach and also in creating awareness. And so we see Kenya Space Agency with their position, they are also going forward in the long term, we are able to implement, together with them, we'll be able to encourage the implementation of dark sky friendly lighting regulations and policy implementation. This is our long-term goal. And so currently what we're doing, okay. Okay, I'm finishing up. So currently what we're doing is we have partnered with the Kenya Wildlife Conservancies Association. This is an association of community-based conservancies whereby they are around Kenya. So we are encouraging them to apply for dark sky place designation. And so currently we have two conservancies in the process, and we're also looking to encourage more conservancies to apply. So by the end of the year, we're looking to encourage to have like 10 conservancies applying for this. So I think that's all from me. Thank you for your attention.
Thanks, Carol. Questions for Carol?
Hi, Carol. Thanks. Marcus Byrne from Wits University in Johannesburg. How do you get citizen science to measure the sky? What instrument do you get them to use? Thanks.
Okay. So for the application, we have options that where for people can collect measurements using any application they have that measures night sky. You have the loss of the night and the sky meter, and then they can log the bottle scale values they get into the application. And also you can use the sky quality meter, and then the measurement you get, you will also input that measurement into the platform. So mostly SQM and any other of the apps. So you're still testing out which one gives more accurate measurements.
I'm hoping she uses globe at night too. As a
Yes,
citizen.
we do.
Yay.
Yes.
Okay, any questions online? Okay. Yeah, one more question, last one.
Is there anyone else who want? Thank you for a wonderful talk. This is Aparna Venkatesan. It's wonderful to hear you address so many issues all of us are thinking about. I wanted to ask you, it sounds like you're taking wonderful steps to address light pollution and concerns about safety. I just wanted to ask you about your experience, how that's playing out on the ground with people, just so that with the changed lighting, has there been any pushback on perceptions of safety, or is it going well? Just what is your experience on the ground? Thank you so much.
Okay, thank you for that question. At the moment, what we have, we are just planning to have the pilot project, so we haven't rolled it out on the ground yet. So that's something we're looking forward to doing in the next few months. Yes. So I'll get back to you maybe when we do that. Yes.
Okay. Well, I think we should thank Carol again. Next one. Okay, the next speaker is Connie Walker. She will be telling us about dark skies protection at NORLAB observatory sites in Chile.
Well, hello, everybody. I'm really honored to be here and to talk to all of you. Just once again, I'm from NSF's Noir Lab, which is our national observatory, optical observatory in the United States. And I'm here to talk to you about the protection of the observatory sites that Noir Lab has in Chile and in Arizona and also Hawaii in the USA. So this work was basically done in collaboration with a group at Noir Lab called the Dark Skies Protection Group, and that I'm honored to facilitate. And the Office of the Protection of the Quality of the Sky in Northern Chile, and you're going to hear the term OPCC used quite frequently, and that's that group down in Chile. And also some work with the Dark Sky International and also the IAU Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference, and I did not name that. We mercifully shorten that to CPS, and that is the organizations that are in some ways involved in what I'm about to share with you. So the economics of astronomy actually can be found nowhere as prominently as in Chile, believe it or not, where we have about 40% of the telescope mirror surfaces and in the world actually reside there. And it's going to climb to 50 or 60% by the end of this decade. So in addition, this region is in which our observatories actually reside are located in a quintessential location for astrodtourism. So it's also economic benefit to the surrounding area as well. The night sky, but the bioenvironment and human health as well. So over the last decades, our observatory staff working with the OPCC were able to provide advice in the development of Chilean lighting laws. At first it was regional, and then since last fall it became actually a national law. And this new national standard is called the Norma Luminica. You'll hear me say that a couple times. And it regulates light pollution and can serve as a model for other parts of the world. So, and our observatory is maintaining compliance with this law, both at the observatory headquarters in La Serena and at the observatories on both mountaintops. And you hear me talk about Pachon and Tololo, Cerro Tololo and Cerro Pachon. Next slide, please. So to maintain the compliance with the new Norma Luminica and to also monitor how the skies are at our observatories are actually changing, we're going to take, we take all sky images of the night sky every 3 months. So we go up at night for a couple of nights, and this is during new moon and on both mountaintops at the same time. So several dedicated people in that group I talked to you about at the beginning, the Dark Skies Protection Group at our observatory. And I'm going to just, if you go to the next slide, the next click, yeah. So that's where one of the 2 observations are located on Cerro Tololo. And go to the next, click again, if you would. And this next one is got to be Cerro Pachon. If you can click forward. There you go. So this is the results of looking at the night sky from Cerro Pachon. Okay, very good, thank you. And those 2 mountaintops, you can see one from the other, basically. They're in Chile. Next one. Okay, see if I can get there with my. Okay, so here we also take pointed measurements. Oh, actually, it's the slide before, please. There you go. So we also take pointed measurements of the night sky brightness towards zenith and actually towards several cities that are on the horizon that are starting to be a little bit showing their sky glow. And we do that every few minutes, every night. And we're starting this project quite recently. And here you see some of the detectors there, actually in a testing phase to see how they correlate with each other on Cerro Tololo. And then there's one that's showing right now. We're going to have several, but there's one on Kit Peak on the roof of the visitor center there. So these are our devices for monitoring every minute of every night. And we'll be able at some point in the future to share that data if anyone's interested. And then the next slide. So this is a couple of devices that we use to try to maintain compliance with the Norma Luminica, the new law. And we also take spectral measurements and the brightness of buildings in the cities nearby. And this is using a sort of a DSLR camera. And also and then with the other device, we try to take measurements with a spectrograph from the mountain of Pachon towards the cities that we need to kind of oversee if they're compliant. So we're starting this project too. This is a new thing as well. So let's go to the next slide, please. All right. So here on the left is part of Chile here, and then on the right hand side you see the area that encompasses both Pachon and Tololo, and this is a very special area. So the map on the right shows about 85,000 acres of land that also includes the observatories. And this is a dark sky sanctuary that was actually certified by Dark Sky International in 2015. And it was the world's first dark sky sanctuary. We're very proud of that fact. So the point of this map is that we are actually have this certification that influences the region, not just for astronomical purposes, but also because of economic purposes in allowing the region around the observatories to have astrotourism, which has been very, very, very successful. There's like 20 in the area nearby. And this, of course, influences what the public learns about astronomy and protection of the night sky. The next slide. So we have a huge education outreach in many ways. We started several years ago with a beautiful educational kit that we translated from English into Spanish so they could use it down in Chile as well. And it tells you about 6 different activities on different aspects that relate to your life, not just astronomy, but sky glow, light trespass, glare, and how it affects animals and safety and energy. All that kind of stuff is in that activity. And then on the the left-hand side is our outreach to the general public. And one great activity they came up with was a box. It's actually a better version now that the kids can go into, and there was a huge line of kids at one of these last events that they go into and experience what a night sky is and what actually sky glow is. So it's kind of a cute activity. And let's go to the next slide, please. Okay, and another piece of outreach is our Globe at Night project, which I'm hopefully, how many people have heard of Globe at Night? Can I see some hands? Oh, very, very good. All right, excellent. This is an international citizen science campaign that has the public, in a matter of less than a minute, rate the brightness of their night sky. And this is done all over the world. 180 countries have participated. We have, more than 500,000 measurements in the last few years. And this is a Chile's participation and some of the other countries there in South America. And so the brighter the dot, the brighter the sky, the darker the dot, the darker the sky that you see on the map right there. And you can actually, it's an interactive map, you can find out data if you want to click on the points online too. So this activity has been very popular all over the world. And we've designed also, this has also been part of, oh, what? It's finished? Oh, okay. Well, we've had an article, a very important article that came out that showed that the night skies are growing by 10%. And yeah, we're almost finished anyway, so no problem. Okay. Next slide is to go on, and might cut into the 2 minutes, I guess. So we've had some international efforts with various conferences in the last few years that are very prominent. You can go online and find out all about these conferences and the reports that came out of them on dark and quiet skies and satellite constellations. Next slide. And also, if you want to learn more about all of efforts recently, we had this conference last October. And one more slide, I think it is, right? We have international efforts as well with UN, and it took a few years, but we actually got them to recognize that astronomy is a space activity. So now we have a 5-year agenda item on dark and quiet skies, just on dark and quiet skies, that all countries can participate in, and that's going to be quite an accomplishment for the future. And I think that's it, right? Hopefully.
One question for
yes, John. Yes.
Connie, I'm puzzled why you're taking SQM measurements every 2 minutes every night. That would only make sense if you expect the sky glow to change on a time scale of a few minutes, but surely it doesn't.
No, yeah, we do it like every 5 minutes, so it's not that often. But yeah,
still, it's not changing from on that sort of time scale, is it?
No, it's not. But
why bother?
Yeah, why bother? Well, I have done this in the past at the locations that are around Chile, Arizona, and we have gotten some extremely excellent results on how the location matters, and it does change on the basis of location. And so we're just trying to emulate the same kind of experiment again and see what the changes are in the past 12 years.
Taking all your measurements in the same location.
Yeah. Well,
or locations.
Yes. Yeah. So we're trying to repeat our.
You're surely aware of the Nyquist sampling theorem.
I didn't catch that last part, John. Sorry. Yeah.
Okay, last question.
Yes, sir.
Thank you, Connie. I may wonder to ask if there is any contribution from African countries in the involvement of dark sky monitoring. Is there any? Just can you give example?
Yeah, there have been a little bit from, I think it was Ethiopia and Egypt, but only a few points in South Africa and Ghana, I think, and Morocco, but not too many, not a whole lot. So we have to do some more promotion in those countries. And I think from maybe Kenya, but yeah.
Yeah, let's thank Connie again. Yeah, the next speaker would be the Noel Store. EU Interact North for sea light pollution monitoring. Yeah.
Thanks. So I'm going to talk about a project that we've been running for the last few years that was funded by the EU. They have a program called Interreg, which combines EU countries together working on projects. And one of the interreg regions is the North Sea. And so this was a North Sea light pollution monitoring project on the eastern side of the North Sea, now that the UK is not in the EU. So one half of the North Sea is no longer part of Interreg anymore. You see there the principal collaborators in the project, though there are lots more people involved. Tobias sitting over there, I'll point at him. So we have many, many students and others involved in the project, and across the University of Groningen in the Netherlands, University of Oldenburg in Germany, and University of Aarhus in Denmark. And so the area of focus that we have is on the Waddenzee region, which stretches from, this is the Netherlands here, through Germany and up into Denmark. And it's a UNESCO World Heritage Site. And it's a tidal mudflat sea ecosystem. The sort of faint picture in the background is my legs stuck in the aforementioned mud. It's a very unique environment in that the tidal mudflats are there. It used to be a bigger environment, but the Netherlands likes to steal land out of the sea. So the Netherlands has taken up some of it now and reclaimed it. So reclaim is a strong word. It's made up of these, you can see these barrier islands, and they actually have barrier reef, but the reef is made not of coral, but of oysters and mussels. So you have an oyster and mussel reef on the side of the islands. Then you have the salt mudflat sea, which is the Waddenzee coming, and then into the land of the countries, which are all very, very low at that point. So all of these cities are very low, and many would be underwater in the Netherlands part in particular. And for this project, our main goal was to develop strategies for long-term monitoring of light pollution in these areas. And we have pairs of dark and bright sites that we're monitoring. There are also some bonus sites that are now, and the German guys also have a mobile tiny observatory that can also do light pollution monitoring as they drive that around. So the goal there was to see what we can do between all of these monitoring systems. I'm happy to go after Connie's talk because she showed you lots of pictures of the kinds of monitoring systems that we use. So I don't have to in my little bit of time. So, but we have that over the region. And in the region, we have also got these, I've marked here, the international dark sky places that are recognized. We have 100% of the Netherlands ones are in our region, all two. So it's not good. A quarter of the German ones and a third of the Danish ones make up these. So you can see around the coast, mostly on islands, but also in Lauwersoog in the Netherlands, so north of Groningen, at the very north of the Netherlands, there is a dark sky park in the national forest that is there too, which you'll see more of later. Why does light pollution matter in this ecosystem? We are not talking telescopes on the top of Chile, which is sort of, you can see the astronomical importance, but here a lot of it is for environmental impacts and human impacts. So we know how humans are affected by light pollution, but also the environmental impacts can be quite important here. We have migratory birds. So this is sort of the west-hand side of the landmass, so migrating birds coming across the North Atlantic flyway. This is the first place you see, and if they're seeing these bright lights and things can affect their navigation for shore. Also, there's a lot of protected species that are in this area, unique to this area, especially around crepuscular, which are ones that like to be out in dawn or dusk. And we have especially some species of deer in the Netherlands that live in this area and are expecting dusk time. Also, if we have hibernating species, they can be affected by light pollution as to knowing when they should be hibernating and not dying because it's wintertime all of a sudden. And then obviously the nocturnal species as well that are in these national forests or these protected UNESCO landscape. It's also economically important for things like the fish management, the cycle of zooplankton providing the food for the fish is certainly affected in harbors and fisheries, as it also works on this day-night cycle. Also some crop difficulties if you have things like seed potatoes, which Netherlands very much exports a lot of, but seed potatoes, if you grow them under blue light, don't make as many tubers as they do under not blue light. So even your seed potato harvest is affected by too much blue light pollution. So there's a lot of these also social economic factors that come into play in this region as well. And in part of the combination of all of these is why that the European Union through this does consider this to be a sustainability issue in the region. So it is part of the environmental and sustainability mission of the Interreg projects. So that in itself was a good spin-off from this project, is that now the EU officially recognizes that light pollution is pollution and treated the same way as other kinds of pollution. We also have a telescope from the University of Groningen in the Dark Sky Park in Lauwersmeer. So last but not least, we do some astronomy, but it probably is least. It's a 25 centimeter telescope, and it is probably the lowest altitude university telescope in the world. The base of the telescope dome is at -1 meter, so 1 meter below sea level. So not like these mountains that Connie is able to put light pollution measurements on. So it's also very interesting in how we're doing this light pollution monitoring through a lot of atmosphere. So a lot of stuff we can do is about atmospheric monitoring. We had PhD students who use our telescopes to work on atmospheric dispersion measurement techniques that are now being used in new telescopes in Chile, for example, because we can test things about atmospheric dispersion a lot better because we've got a lot more atmosphere to disperse. People do appreciate astronomy in the region. The picture on the left here was stacked exposures totaling 27 minutes in a fairly bright backyard near Groningen. And the same on the right was the same part of sky in a 10-minute exposure in one of the dark sky sites. So that makes a very interesting division there. You can see also that SQM measurements, as Connie was showing. The reason also to answer the question about why we do this every 5 minutes is because they're extremely weather sensitive and atmosphere sensitive. So they're sensitive to changes in humidity, clouds, and some of the stuff that I particularly work on is like, how does the clouds affect it? What about the moon angle? What about the moon angle on different amounts of humidity? And all of these things constantly change in the night. Also, you have dew and frost forming on the windows of the SQMs and how that goes through the night with humidity. So you need to know about the dew and all of these things and how that's affecting it. And so those things do change through the night in those 5-minute things. And so we have this whole slew of different stuff that we use to measure and try and compare these from spectral measurements to SQC measurements, as Connie showed. We have other cameras we set up ourselves that are a similar thing. We have these deployed in boxes that also monitor all the time. So we have our cameras sitting at these sites taking images about once every 30 seconds or once every minute through every night after sunset to get those different effects, to see what the effects are of the different weather conditions, different social events that happen, all of these kind of things. And so these autonomous boxes do their thing and send us back the data every day, though they have some capacity if the internet breaks. Of course, lots of problems happen with them, but we're getting there. I've got 0 seconds left to talk. So you can see also there an example of the SQM during lightning. So lightning, it was like a couple of nights ago in Groningen, and you can see that this is all picked up as well as this light pollution. So everything, we have an annual big fun fair in the middle of town, and you can see when they turn it off at 11 p.m. or the lights will go off in the fun fair, and we see that in the light pollution for the city also. We also have an education working group just there that we're just starting, will become active in September. If you want to join that, message me in Slack or talk to me. We've had master theses, bachelor theses, people are working on PhD projects in it. We also have the got now the interest of the Royal Netherlands Space Security Centre, so part of their Air Force, and they're setting up light pollution monitoring and satellite monitoring, especially because they are interested in spying on spy satellites that are spying on them, but they're using some of our light pollution systems, so we get light pollution data and also satellite data at the same time as they're doing that. We had a MSc thesis in public policy we're proud of too, that was with Richard Green and Martin Elvis. We're supporting Lorena, one of my students, who did also bringing this into the policy forefront as well as a connection from the project. We also have a now bigger, sorry, I'm now too long, but we have a now bigger project expanding into the future called Darker Sky that is working in harbors all the way from the end of France up to Denmark. So we have a wider stretch working on that, and also especially focusing on the nocturnal insects, bats, migratory birds, and the human factors and behavioral changes in harbors and ports, both in terms of holidays and in terms of the working fisheries in those places. You can contact me.
Okay, that's thanks. One question for Jake.
You're talking about a darker sky there. How dark is it currently?
Depends if you're in the dark sky site or the bright site. In the dark sites, it can be darker than 20 to 21 magnitudes per square arc second. It's in the Lauwersmeer Dark Sky Park is some of the darkest skies that you get in Europe, even though other parts of the Netherlands are the brightest parts you get in Europe, not very far away. That was my one question. I will be around, so you can ask me questions or message me in the Slack as well. I'm also in sharing things in this session over there too, so I will be backwards and forwards. So sorry that I'm not.
Okay,
here.
I think we should move on, and let's thank Jake again.
Hello, everyone. Can you hear me?
Yeah, we can hear you. Okay, so yeah, so the next talk is Laura Costa, is it?
Yeah.
Okay. You can go ahead, Laura.
Okay. So I am Laura Costa, and I'm going to talk about the effect of the air glow and the solar activity on the night sky brightness measurements. And I'm going to focus on measurements performed at the Parc Astronomique del Montsec in Lleida, Spain. So first, I will talk a bit about the photometers that we are using, the TESS and the SQM. I will talk about the solar activity, the air glow, and the Milky Way. I will explain how we treated our data, and finally, I will show you some results and make some conclusions. So to study the light pollution, we have to take into account that we have natural light sources and artificial light sources. So we are going to study how the natural light sources, as the air glow and the solar activity, affect our measurements. To do this, we perform synthetic photometry using the spectral response of some photometers and night sky spectra of the Parc Astronomique del Montsec. We also quantified how the air glow affects the measurements, adding a factor of synthetic air glow to our spectra. And finally, we compared a long-term evolution of data of the TESS and SQM to see if we can relate it to the solar cycle. So we will compare the TESS and the SQM measurements, which are placed at the Parc Astronomique del Montsec. We have 7 TESS and 2 SQM, and both instruments perform lectures every minute and have a similar field of view. We filtered all of our data, rejecting the moon, filtering the clouds, and averaging the magnitude for each night. Here in the figure, we can see the spectral response of the TESS, the SQM, some Johnson filters, and also the 3DCM that we couldn't include in our analysis because we don't have enough data, but this instrument will be presented in the next poster session by IAU GA. And the spectra that we used is measured by the SAN4B spectrometer. And here we have some spectra of the Parc Astronomique d'Almonsec that we used in our analysis. So the solar activity is a cycle of a periodic change over the sun activity in 11 years. We had a minimum solar activity phase in 2018, and we reached the maximum in 2024. We are focusing our analysis in the air glow, which is the light produced by the interaction of the incident high energy solar radiation with the upper layers of the atmosphere. The air glow is affected by multiple variables as the state and composition of the atmosphere and the solar activity, and it's very difficult to model. We also have to take into account that the Milky Way introduces a brightness in our sky, and it presents also variability during the year, where we have a smaller contribution during the first months of the year. So to analyze our data, we integrated the radiance of the spectra of the Parc Astronomique d'Almonsec with the spectral response of the TESS and SQM, and also for some Johnson filters. And to study how the increase of air glow affects our measurements, we used an air glow spectra from the Zero Paranal Advanced Sky model, and we added the contribution of this air glow to the Parc Astronomique d'Almonsec spectrum. Here we can see one original spectrum, and as we increase this factor of air glow, we have a brighter spectrum. So now I will show you some results that we obtained. First, working on the Parc Astronomique d'Almonsec, we noticed that there was a constant difference between the measurements of TESS and SQM. And we noticed that the magnitude measured for TESS was always brighter. Here we have an example of the measurements of one night of August 2021, when we averaged the measurements of all the instruments. We can see that the magnitude of the TESS is always between 0.1 and 0.3 magnitudes brighter than the SQM. We wanted to see if performing synthetic photometry, we could reproduce this result, or if it was some provoked by some other factor, and integrating only the spectra of the night sky brightness and the spectral response of the instruments, we also noticed that we have a difference between the measurements of TESS and SQM between 0.1 and 0.3 magnitudes. Then we had our spectra, and we added an increasing factor of the air glow of the Zero Paranal, and we calculated the difference between the synthetic photometry of the TESS and SQM magnitude, and also some Johnson colors. And we can see that as we increase this air glow factor, the measurements become redder, and also the difference between the TESS and SQM magnitudes increase. Finally, for the SQM and for one of our SQM and TESS, we had a lot of measurements. For the SQM, we have 10 years of data, and for the test, we have less years, but also a big set of measurements. And first, we can notice that there's a rising and setting pattern on this data that corresponds to the rising and setting disk of the Milky Way. And also we notice that at the beginning of 2020, there's a minimum on the night sky brightness, and it is increasing to 2024 in the SQM. In the test, this effect is more subtle, but we can also notice a minimum of sky brightness in 2020, and we can see that the overall sky brightness increases along the years. So this trend is not so clear, but we can notice that the measurements of TESS and SQM follow the solar cycle. Finally, I will remark some points, and it's that the difference that we notice between the measurements at the Parc Astronomique del Montsec between TESS and SQM can be explained by the airglow contribution, because the Parc Astronomique del Montsec has a characteristically red airglow contribution, and also the time evolution of our data presents a decrease in brightness during the period of minimum solar activity, and this result shows a relationship between the night sky brightness measurements and the solar activity that we have to take into account. And to confirm the results, we need to analyze more data and other locations over a longer period of time. Thank you for listening, and if you have any question, I am happy to answer.
A few questions for Laura.
Hi, it's Richard Green, and those are really interesting data. So were the final graphs that you were showing us, were they filtered to be only clear nights?
Yeah, we filtered all the data. We filtered the moon altitude higher than -5, and also we filtered the clouds performing chi-square test. And then, as we had a lot of data for each night, we averaged the magnitude. So yeah, we filtered the data, and it was all clear nights and without moonlight contribution.
Since you did all that work, you get to speculate. So it looked to me like the scatter was around 1/10 of a magnitude, 1 sigma for that. Do you think that's night sky brightness variation or residual transparency, or a little of both?
Well, I think that a little of both, because the night sky brightness is very variable, and I filtered the moonlight contribution and the clouds. But there are some other factors that can affect the night sky brightness measurements, as the brightness of the surroundings and the aerosols and the state of the atmosphere. So we have scattering because of other variables, and also from the test.
Last question.
Laura, this is Ruskin from Dark Sky. So our Dark Sky Places Committee has been having a long discussion about the impact of airglow and various factors on night sky brightness over the years. And I'm interested whether there's any indication in your data about the change as you go from more pristine sites to more light polluted sites, whether the artificial component swamps these signals, or whether they're still present.
I am now working on analyzing spectra from light polluted locations, and the difference between the measurements of TESS and SQM reduced, but we have to take into account that it also depends on the kind of lighting, because in some cities they use different kinds of light, of lamps, the wavelengths of each lamp is different, and we can mix it. I don't know if I am answering well your question.
It's okay. I think we should thank Laura again. 4 minutes for just general discussion or open discussions. Yeah. Anyone would like to start asking questions or maybe giving suggestions?
What might people be doing in their own communities that are similar to these measurements, or anything else that you might want to talk about that you have a question on with regard to measurements or your efforts?
Laura or Anna, could you give us a little preview of the free dark sky meter and the status of it, and when and how people will be able to access it?
Well, this was going to go to the 2-minute poster presentation.
You can do it twice. I need to hear everything twice anyway. So.
No, actually, well, if you want, I can summarize it right away. Yes. We are a group of astrophysicists and software engineers combining joint efforts, and we have developed this new device called Free Dark Sky Meter, which is very easy to handle and which performs quite like SQM, and this is very cheap, and it will be the building instructions are already public in a web server, and the idea is based on open source and open hardware, and yes, and the basic idea is that we democratize measuring. Is complementary to all other methods to democratize measuring dark sky. You build it at the school, you put it in your garden, you have it on any roof actually, and then the data will be collected to a server and will be mixed with modeling of the natural dark brightness of our sky based on Gaia satellite survey data. This model is called Gambons, and Free Dark Sky Meter and Gambons go together into a project that is named Gaia Dark Sky for Sustainability. So actually, I think we can skip the poster presentation later on. We have several devices already, especially in various places, measuring, and mostly in Spain. But this one in particular is ready to travel. If especially or particularly could be useful if any African observatory would be interested in plugging it there, or can go anywhere actually.
How much does it cost?
Well, in pieces, if you build it yourself, we estimate $40. All of it with a laser printer and everything. And this one in particular, as I say,
it's calibrated up to what magnitude?
I mean, absolute calibration, as we know, is an issue. That's not the point, but it can be relatively intercalibrated with SQMs, and it performs just as well. I mean, it's not a prototype. We have gone through many phases, but it's not a prototype anymore. It's a working device. So if any of you could be interested in bringing it home, it needs electricity supply and Wi-Fi. But otherwise, and talk to us, of course, we are most happy to start collaborations all over. So I think, I don't know if this was enough. I beg your pardon? I am from the University of Vigo in Spain, but we collaborate with the University of A Coruña, is where Minia Manteiga is also here, and now we give you all the contents you need, and then we collaborate with the group of Laura, that's what she mentioned, in the University of Barcelona. I mean, we are a wide
group.
Thank you very much.
Well,
yeah.
thank you. But please don't make me talk again with the poster.
We're going to make you give it again anyway. Thank you, Anna.
Okay, thank you. There was one question online for Laura. Have you been able to compare your results to what the National Park Services deployed system measures? Are you still around, Laura?
That's the United States National Park Service.
Okay.
Yeah, I'm here. I haven't compared it, but I will be interested. And Zenny replied me, and I don't have access to any of their systems, but yeah, I will be happy to collaborate with them.
Sorry. Okay, thank you. I think we should move on to the lightning talks. When we say lightning, we really mean. Yes. Okay, so the first talk will be by.
Yeah. Yes. Hi everyone, I am Abdelkarim Bouskri, associate member from Okeim Observatory at IAU University. So our talk is about enhancing satellite observation capabilities and the role of Okeim Observatory. So our works is in different, as you see, we make observation facilities in Oka. As we see, we observe with mini telescopes, small telescopes. For example, we have most telescopes with it's a telescope with 50 centimeter of diameter. Our telescopes also in alt-azimuth mounter that survey also and observe satellite, and we have many small telescopes that we can found in Ashau Observatory to observe satellites. So to did that, we did the framework that we can planify observation, as you see, and also we did the data process. For data processing, we filter all the image that we take and we remove the artifact images, and also we did the photometry to calculate the magnitude of the satellite. So also we did the framework to make statistics in our observatory. So the number of satellite observed in our sky. So we can find in this figure that for the latitude less than 40 degrees, we can find in each degree more than 100 satellites for each 5 minutes, I mean. So we did also the framework to calculate the sky coverage, is the probability to find the satellite in 1 square degree in the sky, and also the main statistics that we can find from one night. We can find a lot of satellites between the magnitude of maximum magnitude accepted is 8 also, and we have, for example, in this histogram, the maximum number of satellites is 7,000 satellites for each magnitude. So that's it, and if you have any question. Okay, yeah, I will ask you. Okay, thanks.
This is the next one. Yep. So Vladimir Waszkowski or Stanislav. Is Stanislav here?
Yes, I'm here. I'm online, if you can hear me.
Okay, go ahead.
Yes, so but I cannot see the presentation on the screen right now. Can you share it? Yes, right. So, hello everyone. My name is Stanislav Karpikov, and together with my co-author Vladimir Pashkovsky, we present a new technology that can protect astronomical observations from sky glow, light pollution, and the technical solution we present you today suppresses sky glow in the field of the telescope, and not only the direct light from the lights, but also the diffused light in the atmosphere, reflected light from roads, surfaces, water, clouds, and other objects. And most importantly, the approach is suitable for facade lighting and advertising lights. Something that is like really growing today, and something that poses a great problem for the astronomy. So the idea is to use the LED lights in switching mode using frequency higher than the human eye can notice, which also safe for the environment. And we install a shutter on the telescope that is synchronized with the lights and opens the exposure when the lights are in the off phase, and it blocks the exposure when the lights are on. So they work in different phases. And we successfully tested the system, and we are sure that it is suitable for even big cities and wide range of telescope types. But of course, there are some technical challenges. The shutter should be able to withstand millions of cycles per year, and so we have to achieve precise synchronization, adjust the duty cycle and other parameters, but we were able to achieve some great results that we present in this presentation. And the next step is to adapt this system for other types of lights, for LED TV screens used in advertising, and for some many modern lighting systems. So that's all. Thank you.
Thank you. Next is Christopher Badeli. Christopher, are you online? We'll move on to Daniel Gonzalez. Daniela Gonzalez. Is Daniela is in here or online? No? Okay. Move to the next one. John Valentine.
Hi, everybody. I know many of you, John Barentine, and the hat that I'm wearing for this particular presentation is with the Dark Sky Southern Arizona chapter, and I'm presenting on behalf of my co-authors who aren't here today on a pilot study that we're doing for sort of more coming attractions. Can I have the next slide? Where? Oh, okay. So I pulled, instead of putting up the entire poster because it's impossible to read, here's just a couple of the highlights. What we're trying to do is put together a network of SQML and test devices across our region, which is Southern Arizona. We're down there in the southwest of the United States, and we're very close to the US-Mexico border. We're talking to Dark Sky Mexico about situating one in the Sierra Pinacate, which is an extremely dark part of northern Sonora State in Mexico. And the picture over there on the right shows our territory. The false color overlays are from the New World Atlas, indicating the expected amount of sky glow. And then each of those little markers on there is either a place where we have a monitor right now, or we want to place one, and we're trying to get the funding to do the placement of the rest. What we've done so far is used one monitor that's been placed in the Chiricahua Mountains of Southeast Arizona for about the last 7 or 8 years, and we were using the data from it to develop some software that we then want to apply to the data from the other monitors when we start to get it, that does automatically all the filtering for removing clouds and moon and Milky Way and zodiacal light and all the other interferences. And we used it to see if we could detect the rise of solar cycle 25, which is mirrored in the blue trace up at the top. That's the 10.7 centimeter radial flux. And kind of, sort of, I think you can see a bit of a rise in the sky brightness in the cyan colored trace on the bottom. We compared this to a long-term trend derived from about 200,000 sky spectra in the SDSS and BOSS survey data from Apache Point in New Mexico. And there they're looking over a much broader continuum than we are with the passband of the tests. And we're finding that we can better detect the rise of the solar cycle matched by the radio flux with these broadband detectors, but a narrower range of wavelengths that contain some of the air glow lines than if we take a very wide, about 350 nanometer or so wide window with SDSS and BOSS. So have a look at the poster. Please come and talk to me about it, and I'd be glad to discuss with you. Thanks.
Next is Presmislav. Okay. Okay.
I will take it.
Yeah.
Hey everybody, so I'm Przemek Mikołajczyk and the long version is Przemysław for everybody to remember, but I understand it's not easy. So I'm here to advertise the project that we do at the University of Wrocław. I'm also a part of University of Warsaw, so that's why it's here. The project name is measuring the quality of the night sky at Polish astronomical observatories. And it's called the Alps Monitoring Network, which I can probably advertise also on the t-shirt. So if you want to buy one, just contact me. Okay, so I didn't put everything from the poster here on the presentation, just not to mess it up. So the purpose is to build such boxes, as you can see in the upper left corner, to put inside all the measuring devices that we can find. So far, there is an all sky camera inside and an SQM meter. I guess we can replace that with the free dark sky meter because it's an order of magnitude cheaper. So maybe we can put tests inside as well to maintain the same price. And we did it, we constructed it so it works in a fully automatic way. You can put it anywhere, just plug it into your socket and into internet cable, and the data flows automatically to our server, and then we can analyze it, display it for you. So it is a perfect device for an astronomer, for astronomical observatory, but also for schools. You don't have to do anything. You just go to our website and there is a data archive. It will be free and available forever. We want to track the light pollution in the observatories, but we can track it anywhere. So we also do this nice pictures for the outreach for kids and for schools. And as you can see in the upper right corner, those two pictures are exposed exactly the same, but the same cameras. And those two places are 50 kilometers apart. So such pictures really show you how the sky deteriorates. If you want to see a little bit more about our project, then please contact me or go to our website. Thank you very much.
Well, I would Imagine Mohammed is not here. Mohammed? Online? No. Justina?
Hello, my name is Justyna Olszewska. I am PhD student from Poznań, Poland, Adam Mickiewicz University. And beside my PhD work, I am also a part of collective, popular science collective. We call it Good Night Collective. And this is a group of astronomers and artists working on the light pollution topic and also dark sky protection. And we do many popular science workshops, exhibitions, and projects. During the last year, we did social project with one of the most famous clothing company in Poland. It's not working? Okay. So here you have the photos of this project. And also during the last year, we are working with Alp stations because we want to build 2 stations in 2 strategic points in our hometown. Thank you.
Okay, the next talk is Anna. Sorry, Anna. Okay, go ahead.
Well, hello again, and thanks to the organizers for this double opportunity. As I said, it was the green one, right? Okay, and the details are in the poster, so please visit it later on. As I said, this is a device not to substitute anything, it's just to complement all the other ones. We know already that light pollution is a terrible global environmental problem, very difficult to tackle, and but perhaps not impossible to solve, especially if we make friends. So it's worth trying to mitigate it at least. And 2 points, as we have already said, can be key: to raise social awareness and to widely monitor. There are the commercial solutions for monitoring as SQM. And in our group, as I said before, we are astrophysicists and software engineers combined. And we come with this proposal. I repeat, it is based on open software and hardware. It is very easy to handle, performs similarly to SQM. It's cheap, it's quite cheap. And the building instructions are public. And we also will collect and save the data, will be public, everything, and combine it with modeling of the, I don't know if to come closer or not. That backwards. Okay, it's better here. Okay, thank you, sorry. And basically that, thanks. Basically, the idea is, as I said before, we would like to spread as much as possible. The same way people have a parabolic antenna and a smartphone and put it on your roof and be informed, at least have an idea all the time how dark the sky is above your head all the time, affordably, regularly and affordably. That is the idea. And this one in particular is ready to travel if at any observatory or something would like to bring it back home. Electricity and Wi-Fi. And in any case, please talk to us if you have any interest, and we will be more than happy to collaborate with everybody. Thank you very much.
Okay, the next speaker is Amira. Fatima Kati lady.
Oh, all right.
Do you want to move? Yeah,
no, you can.
Okay. Anyway, if you want to move, then you press the name.
Hello, everyone. My name is Amira Lunes Din, proudly representing both Mozambique and Ecuador, and currently studying astrophysics in Chile. Being here at the IAU General Assembly is a dream of mine come true, and it's a privilege to share our vision with you. My journey has always been guided by a desire to uplift my community and make a positive impact in Africa. In 2022, along with fellow astronomy enthusiasts from Mozambique, I co-founded Patima Katingeleti, meaning shine of the stars. This project goes beyond addressing the lack of electricity in the rural areas of our homeland. It is a social initiative aimed at improving the quality of life and equal rights for communities. By reducing light pollution and preserving our precious dark skies, we aim to create a space for appreciation and inspiration while fostering the development of Mozambican astronomy. Recognizing Chile's leadership in outdoor lighting policies, I invited my Chilean colleagues to join our initiative, encouraging bilateral cooperation between our nations. Patima Katingeleti is a pilot project with the potential to expand across Africa, addressing similar issues in other countries. Our mission is to bring light to underprivileged communities, not just in the physical sense, but also through education and empowerment. And we believe that by illuminating their world, we can help African communities rise, shine, and reach for the stars. As Mandela once said, it always seems impossible until it's done. Thank you so much for your time and attention.
Well, should I try and go back to the other two or three, or should we just? Do you see Christopher? It's not online. And oh, sorry. So and Stanislav. Oh,
Yes, it's me. I have already presented this.
sorry. So it's Christopher. Daniel Gonzalez is still not available. Okay. Oh, you presented as well. Yeah. Okay, I think that should be all right. Let's just thank all the poster speakers. Oh, is there one left? Yeah. Okay. Yeah, Dancing with the Stars. Yeah. Yeah. Okay, we're gonna get them. Hey, but anyway, before we go there, so I suppose most of this and posters will be downstairs. You can go and see them at 3:00. Yeah.
Of water, of preaching to the choir. So I'm mixing my metaphors, but it's fantastic to hear you guys so interested in keeping a dark sky. And I'm going to tell you why dung beetles need a dark sky. So it would be great to see you after lunch. Thanks.
So since this is a special talk, we request that you come here at 1:00 to hear him. So if you can grab lunch, feel free to have it in this room if you want to. Don't tell them I said that, but we'd love to see you back. Thank you so much.
Thank you.
Good afternoon, everyone, and thank you very much for joining us for this very, very special session. I'm just going to quickly give a brief introduction to our next speaker, who is a zoologist and emeritus professor from Wits University. This is Professor Marcus Byrne. I'd like to give him a round of applause to bring him up to stage. There you go. Very quick.
She said it would be quick. Okay. Thank you. And thank you for inviting me to this meeting. It is a great privilege to be amongst other scientists, and I haven't a clue. I can't do the maths, so don't challenge me with the astronomy. Dung beetles at an astronomy conference. What's going on? Next, they're going to find water on Mars. You know, it's just ridiculous. The point is, dung beetles are actually very good astronomers because they spend a lot of time looking at the sky. And that's what I'm going to talk to you about, is their celestial compass. And really the final point that I'm going to make is that they are also in need of a dark sky. And I think that's where we come together on this. So, you know, it's something that's in every agony page of every magazine. Everyone needs a compass in life, but you do, because any organism to move across the planet needs an external reference cue that they can orientate themselves to or from or away or against. And dung beetles are exactly the same. What about humans? In a featureless landscape, we get lost. So in places like the desert or in Arctic areas, we will walk around in circles because we don't have a particularly good reference cue, but also because we are map builders. We've got very large brains, some of us. My wife will testify to this because I cannot find my way anywhere. But this is my route out of Wits University, and I can describe it to you because I can describe it by the landmarks. We build mental maps in our heads using the landmarks. I go down, literally, interestingly, past the planetarium, which I'll show you in a little bit, and I turn right at the traffic lights, and then I go past the petrol station, and then I can tell you all the landmarks that are on the way home, and I usually get there. If you're an animal that either has a small brain or is moving across a featureless landscape, this is the bar-tailed godwit. It migrates pretty much across the oceans, completely featureless landscape, 6,000 kilometers to Siberia. What sort of orientation cue does it reference in that sort of circumstance? It clearly cannot use landscape landmarks. And the obvious one, and you all know this, I'm sure, is that they use celestial cues. And the brilliant thing about a celestial cue is it is so far away, there is no parallax effect. So relative to the cue, it doesn't matter how you move, the cue stays always in the same spot. And that is the key difference here between artificial light and celestial light, is the parallax effect. And so what I would like to propose is that we look at this problem through the eyes of this fella. This is a very beautiful dung beetle. I think you'll agree with me. We in this country have got 800 species of dung beetles, so there's plenty of them. 6,000 species worldwide. They are very numerous and they are very important in all sorts of ecosystems. And you might think, well, why choose a dung beetle as a representative of an organism that is using celestial cues? And the reason is this passionate relationship that these animals have with poo, because they cannot resist it. We don't have to train them. We obviously have to feed them. That's the icky bit, but they will respond to dung and make a ball and roll it under pretty much any circumstances we put them under. So just to finish the icky bits, people always ask me, but what do they do with it? It's pretty obvious. They eat it. And that's a science in itself. They use it as a breeding source. So this is a larval dung beetle inside a lunchbox that mum has made for it, and it's eating its way out of the lunchbox, so it completes its development in there. And the other thing is they use it for romance. They use it to make a friend. You down the pub, you meet somebody, you get a takeaway together, and off you go, and you never know what the night might bring. So dung is an essential component of the lives of these animals because it is a vehicle for their genes to get into the next generation. And that makes them extremely competitive, and they fight over it. And what we've done here is, this is a speeded up image, but every time an individual crosses the barrier or the line into the arena, so you're looking down on a pile of poo here. I hope you've had a good lunch. And then every time they have a fight, they get a red dot. And every time they exit the arena, they get a blue dot. And all you need to look at is the preponderance of red dots to blue dots. So the blue dot is a successful escape. And it's a tough world being a dung beetle. You are going to get into a fight at some stage in your career. So how do you avoid the bun fight at the buffet bar? You roll your ball in a straight line. And how do we know dung beetles are rolling their balls in a straight line? Well, we give them a little barrier. That's, in the end, the video didn't work properly. We give them a little, let's see if I get this thing right. We give them a little ramp to roll over. They roll up the ramp and they fall off on the other side. They have to reorientate themselves. And what we do is we compare the original approach angle versus the departure angle. And we can ask them, well, do you know which direction you're going in? And each of those dots is a dung beetle. You step on those ones, that you spoil your data set. We don't really, we are highly ethical. But the average is 1.2 degrees. Do those beetles know where they're going? Absolutely, they are going in a straight line. And the question then is, well, how do they do it? And the obvious thing is to use a celestial cue, and in this case, it's the sun. So Marie here is holding a mirror, and she's moving the sun across the sky 180 degrees. I told you we used, well, I didn't tell you, but we used primitive equipment in our experiments. And every time the sun apparently shifts across the sky by 180 degrees, the beetle does a 180 degree turn. You know, you've got to love these guys, because you can do this, you can punish these things over and over and over again, and they just behave themselves. And you repeat the experiment, and you end up with a data set that looks like this, that you can then statistically prove that under the influence of the sun, they head off in one direction. And if you shift the sun across the sky with a mirror, they do almost 180 degree turn. So we do a streetwear in dung beetle outfits. We also do boots, and I kid you not, but that's another experiment. The other way to ask a dung beetle is, are you looking at the sky, is to deny it a view of the sky, and we put a hat on it. And this is what happens to a dung beetle with a hat on. It clearly hasn't a clue where to go. It is completely lost. It's quite happy to roll a ball, which again is why we love them, but it cannot see a celestial cue, and therefore it is completely lost. Now, there's a particular time of day when the sun is actually a useless cue, and that's when it's overhead, when it's at the top of its, is it the azimuth? The zenith, that's it. Azimuth is this way, yeah. Because think about it, if it's on the horizon and I move relative to that cue, I know which way I'm moving. If it's overhead, I've got no idea which way I'm pointing. So how do dung beetles cope as the sun climbs higher in the sky? And as you can see, what we do here is we measure, again, rolling behavior. And basically what we're doing is comparing roll 1 to roll 2, and then calculating an orientation error in degrees. And when the sun elevation is high, then there's a much greater error than when the sun is at a medium or low angle in the sky. So they have a problem at midday. And the question is, well, what do you do with a celestial compass when the cue is no longer reliable? And in the case of a dung beetle, you switch to an alternative cue. And this is a fascinating thing because one is a visual cue, and the wind as an alternative mechanical cue is sensed by a completely different set of sense organs. And nevertheless, we're able to show, literally again, very simple equipment here, using a fan, that the beetles respond at the midday. And look at the shadows here. You can see that the sun is literally directly overhead. We switch on the blue fan. There's Basil doing his work. Beetle does a little dance. Guess what? Heads off 180 degrees in the opposite direction. So it switches with a tiny brain from a visual cue into a mechanical cue immediately. And again, we can raise a data set that looks like this, that there under the white fan, it headed off in this direction, and under the blue fan, it heads off in almost 180 degrees in the opposite direction. There is another time of when visual cues, and particularly the sun, can be interrupted. And that's when it goes behind a cloud, or it goes, the beetle rolls under a tree or something like that. And what else? So does this compass fall apart? And the answer is no, because in fact, the beetle has got a whole series of compass cues that it can fall back on. And again, polarized light is something that you and I can't see in the sky, but insect eyes per se are the way they're built. Insects have difficulty in avoiding seeing polarized light. And in fact, some insects have evolved a particular eye type to try not to see polarized light. The important thing about polarized light is that it forms a pattern, a circular pattern around the sun. And as the sun moves towards the horizon, that pattern moves from being a circular pattern to literally a linear pattern in a north-south direction across the sky. And that's good for us because now, even though we can't see it, we can manipulate it. So if we go out at dusk and put a filter on the ground under an alignment with the polarization pattern that we know is in the sky, so there's the filter, we pop a beetle under the filter, and then we allow the beetle to roll out of the arena, and we record it as we normally do. Then we turn the filter. And if the beetle is looking at the polarized light, it should do a 90-degree turn as well. Okay, so put your money on the table. Let's take a bet. Our dependable little dung beetle is doing its stuff. This is under infrared light because it's at dusk, and we also want to see through the filter. Basil is our beetle wrangler as usual. We repeat the experiment because we want to make sure that the beetle is actually determined to go off in that direction, and because it's a wonderful, dependable dung beetle, it's not always the same, right? Beg your pardon? It's not always the same subject. No, not always the same beetle. or basil. Yeah, it's always basil, but the beetles are Deirdre, Daphne, Eric, Francis. You know, they do occur in their hundreds. And like I said, there's 800 species, and usually, and as you saw, at a dung pat, you get massive competition. So you get many, many beetles, and you take your pick. Okay, so anyway, if you noticed at the same time, the beetle did a 90-degree turn. Okay, so there is another time when the beetles are don't have a celestial cue, because obviously they can use the sun. If it's a nocturnal species, it can use the moon. It's the same story. It's just a bright spot in the sky. If the sun isn't available, it can use a polarized light. It can also use a spectral gradient that's in the sky. It can use an intensity gradient in the sky. We've tested all these things. It can use a color gradient in the sky, and it can use these cues if it's a diurnal species during the day, and the nocturnal species tend to be able to use the same cues if they are available at night, if the moon is available. But there is a time when what's left in the sky are the stars, and in particular the Milky Way. And I'm going to make an appeal to the astronomers that show pictures of the Milky Way, because we discussed this last night. We gave a public lecture. That picture of the Milky Way that was shown earlier shows these billowing sort of clouds of the nebula. I've spent my life under a desert sky looking at the Milky Way. I have never seen anything like those photographs. That's the camera lying. No, in the Kalahari desert here. And we should have a discussion about this, but I think you're selling the public something that they can never see. And I think that's an important thing as a scientist, is don't sell a lie. Anyway, that's another issue. Okay, so what about under the stars? And this is what we won the Ig Nobel Prize for in 2013, by showing that dung beetles can find their way using the stars. And at this stage, we weren't sure whether beetles could use landmarks or not. And so what we did was we built this arena. So we didn't observe anything because we were worried even if we stuck our head over the side of the arena or stuck a camera over it, they would be able to see us silhouetted against the sky and they would use it as a landmark. We now know they don't use landmarks at all. So this whole thing was done in secret. We were on the outside. I was sticking beetles up through the middle of the arena. And look at these pockets. We'll get to the pockets in a minute in the next slide. So those are the pockets there. This is the inside of the arena. The beetle gets raised up like the Phantom of the Opera coming up through the floor here. And then what we do is we time the beetle, tiny footsteps across the surface of this arena, waiting for it to emerge into one of the pockets. And the theory is if it gets lost, it takes a longer path and it will just take longer to come out of the arena. And you know what science is like? In the end, it's boring. So we put money on it, which pocket the beetle would arrive into. And it's amazing how you can entertain yourself in the Kalahari in the middle of the night, winning £2 on dropping into a particular pocket. Anyway, this is the data we got. Takes it about 40 seconds to head out underneath. If we put one of our famous caps on it, it takes almost 2 minutes to get out. It is clearly lost, and it is significantly different timing. Unusually in the Kalahari, we had an overcast night. And again, we got a significantly different from this, but significantly the same as when we put a cap on it. So these animals were able to use the stars. But this was the best bit of the whole story,
is that we were able to then go into a planetarium. And you're all astronomers, but for a biologist, there's two places you want to work. One is in an aquarium and the other is in a planetarium. And this was just the business. Because at WITS they're getting rid of it now, this Zeiss projector from 1947, I think. It's a beautiful bit of kit. And it gives you a spectacular night sky with these beautiful pinpricks of light. I think these modern sky domes with a projector don't produce the same sort of light at all. But really what was important was that it projected the Milky Way, so we could have the Milky Way on its own. It had 4,000 bright stars and then about 4,000 dim stars and about 18 bright stars that we could also manipulate the sky under that. So you've seen this data from the field, and what happened in the planetarium is that we got exactly the same result. That we were able to use the artificial stars and the beetles were able to orientate with that. And then we were able to manipulate the sky even further. We took out everything except the Milky Way. They worked with that absolutely fine. We took out the 18 bright stars, they were fine. Thanks. We switched it around and they couldn't navigate on the 18 bright stars. And that's because their resolution of their eye is around about your fingernail held at arm's length. A dung beetle cannot resolve a star. And I think that is important to our dark sky consideration. Okay, so this is our summary that during the day, the diurnal species, they can use all these different celestial cues and a mechanical cue. And then at night, we get these pretty much the same and include the stars in the nocturnal species. And how do they do it? We have now tested this, it's during the dance, this little dance that they turn around, they do a 360 on top of the ball. They're actually taking a snapshot of the sky and they're looking at, say, the position of the sun. They remember that and then they just try and match that image on their retina with what is in their memory. And if they've got a hat on, they get lost. And what is really fascinating is that we can give them a completely unnatural sky. We can put the sun in opposition to the polarization pattern. They don't care. They will match that pattern and continue to go in the direction they want to go in. Okay, so what we've got is an animal that is clearly sensitive to the sky, whether it's during the day as a diurnal species and particularly at night as a nocturnal species. How do they deal with an urban environment? So you've got this image in your head. There's a dung beetle on one of our boards. And let's look at the environment that this experiment is taking place in. This is outside the gate of one of the gates of my university in downtown Johannesburg. And clearly this is a massively light polluted environment. And what you've got is an animal that is looking for a distant celestial cue as a cue that will not suffer from parallax. And then you've got it moving through an environment like this. And okay, it's a dung beetle, who cares? I care a lot, we can talk about dung beetles. I can make you care about dung beetles. But this, as a representative of thousands and thousands of species that move around at night, in millions of individuals of those species that move around, this is an animal that we can manipulate and we can get it to do experiments for us. And these are the results that we get from working with this animal. And the experiment we did was we worked literally on the same night. There's a team in the bush out where they can see the Milky Way. And then this is the team in Johannesburg where the sky glow is so bright that you literally You can't see any celestial cue there at all. And these are the data we got. So in the bush, under the dark sky, we got the normal dispersal. In the light polluted habitat of downtown Johannesburg, we got this beaconing effect, which, you know, it's disturbing the animal's behavior. It's moving towards the brightest light. They're not dispersing properly. Whoops, sorry, let's go back. They're not dispersing properly, but they're still managing to move across the landscape. If we remove the beacons at low altitude, then they are completely disorientated and they get completely lost. They cannot orientate themselves without the night sky. And again, it's something that I don't need to tell you, that this is part of our culture. You know, this astronomy clearly is the oldest science. We've been looking at the sky for as long as we've been humans, and now we're losing it. 30% of the human race can no longer see the Milky Way. And I think that is incredibly sad, because as I'm aware that you guys know, it's so much part of our culture as well as part of our science. So the obvious thing, and I think this is what I give lots of public lectures, and I give it to garden clubs and whatever, and I say, just turn out the lights. And I think that's the message that we need to bring home to everybody. And just to say thank you for listening. And these are the people, a lot of people that I work with over this. And if you want to know more about dung beetles, I have written a book with another colleague, and it's called Dance of the Dung Beetle. Thank you.
Thank you. Thank you very much. Do we have we've got some time for some quick questions? Yes.
Thank you for your talk. One of your early slides showed the godwits flying from New Zealand to Alaska via China, which they do every year, thousands of kilometers of ocean without stopping. And I think, you can correct me if I'm wrong, they use both the stars and the Earth's magnetic field.
Yes.
Do the dung beetles use magnetic field?
Good question. Absolutely not. We know that they don't use the magnetic field, because when we put the cap on them, they're lost. So there are ants are very good navigators, and they do use the magnetic field, geomagnetic field, but dung beetles absolutely not. And that's why they're such an important animal for our experiments, because they literally use celestial cues exclusively.
You said beetles can't resolve stars. Humans can't resolve stars either, but that doesn't stop us from seeing them. So can we be sure, you know, the image of a star is say an arc second, and we can resolve 2 arc minutes, and you're suggesting a beetle could resolve a degree, but in theory, that shouldn't mean that they can't detect bright stars.
Well, as I said, in the planetarium, we did test them with we used 18 bright stars, and they just couldn't orientate themselves.
Hi, I have a question. So how do they deal like under cloudy weather?
They stay at home. No, it's a very good question. I work with Swedish colleagues, and they take beetles back to Sweden every year, and they've rolled them under Swedish skies. Those beetles are completely lost. So their activity is driven by rainfall, warm weather, and they tend to prefer sunlight.
We've got an online question from Tesni Pugh. Is there a broader ecological impact of lost, quote unquote, lost dung beetles?
I don't think so directly, because you don't get dung beetles in an urban habitat usually. But as a representative of organisms moving at night, I think that's what their importance is because we can manipulate their behavior so well, and we know their behavior so well, that they, I think, represent all of these other insects that are moving around at night. And we can tell you what happens to these guys, and by inference what's happening to millions of other insects.
Thanks. Following on your comment that they can resolve stars, and I tend to think that then they see the Milky Way as a bright stripe maybe or something like that. So in this sense of we shouldn't be selling things that are not real, right? Your
Okay,
comment on the Milky
and I'm
Way.
the worst proponent of the thing.
So I work on the protection of dark and quiet skies from satellite constellations, right? All this idea of stars moving from satellites reflecting sunlight, for example. So do you think that moving stars as many satellites in the sky could affect the dung beetles or not?
No.
Yeah.
Yeah, I think we have time for one more question. Okay. Okay, two more questions.
Also, baby turtles, which are reptiles, get lost.
Yeah.
The same way. So
yeah.
larger animals.
Turtles. They've done lots of work on turtles.
Different effects that you mentioned. One of them was polarized light. And because we can now both measure and model the polarization of the light of the night, the diffuse light of the night sky, and we know that sky glow from the ground can be polarized by its interaction with the atmosphere. How significant is the sensitivity to polarized light? And do you think it would be a problem if, in comparison, natural skylight doesn't have a polarization signal?
Okay, that is a really tough question because they are very sensitive to a naturally polarized sky, and they can, and I can't remember the data. I wish I could run it off the top of my head, but it's sensitive to the degree of polarization and what's the other measure that you have of polarized light at night? Yeah. And so I didn't know that sky glow was polarized, and we've never tested it. So given that they don't really care whether it's what we've done during the day with a natural sun versus polarization in the wrong plane, I don't think they would care. As long as it's a steady signal, I think it wouldn't matter.
Unfortunately, that's all we have time for. But can we all give a round of applause to Marcus? Thank you very much.
That is fantastic. Thank you so much, Marcus Byrne. Now we will return to protecting the night sky for other species of dung beetles like ourselves. And we will start with a talk by Federico Di Bruno. Federico, have we straightened out? We're going to share it on Zoom? Okay. Federico Di Bruno, there we go. Excellent. Well, tell us about RFI management at SKA.
Good, amazing. I can use this, and I think I can advance this, right? So, all right, perfect. I have 12 minutes, something like that, right? All right, I'll try, don't worry. Okay, so hi everyone, I'm Federico Di Bruno. I work on the SKAO, and you might have heard me talking about dark and quiet skies, so the CPS. This talk will be a little bit different. I'm going to just talk about how we deal with RFI or interference in the observatory as in a holistic way. So just as an intro, these are our two telescopes. On the left, SKA Low in Australia. On the right, SKA Mid in South Africa. We are in construction of the telescopes, and you have here the frequencies that the two telescopes cover roughly. I'll go quickly on this. Hopefully you were able to see some of the other talks about the SKAO, but basically we have interferometers in the two sides with a lot of antennas around the sides, left mid, low, and right mid. And the particular thing about our radio telescopes is that we have radio quiet zones protecting them, covering very, very large frequency ranges. You see low on the left, mid on the right. And the interesting thing is that you see here this white or yellow, lines in there. Those are the radio frequency astronomy protected bands, right? So those are protected for radio astronomy internationally. But you see that these are all our frequency ranges. So for that, of course, we have our two radio quiet zones, which are extremely large areas in the two countries. This one, just to confuse you, I tried to put mid on the left and low on the right. Sorry about that. So this is South Africa and Australia. And you see that these are very large areas where the country has put legislation in place to use the radio frequency spectrum in a very particular way. This doesn't mean that in there are no transmissions at all, radio transmissions at all, but it means that the country regulates strongly what happens in these areas with the use of the radio spectrum or the use of transmitters. So, and one important thing is that radio quiet zones do not affect air or spaceborne transmissions, as I hope you have heard me talking about this in other presentations, which I'm not going to go into detail here. So my idea is to try to explain to you briefly and maybe spark some questions that hopefully we can answer later on how do we manage RFI in the SKAO. So we divide RFI in different parts. So we talk about internal RFI, the things we generate in our telescopes, in our infrastructure, what we produce. Construction RFI, which is a very complicated thing because we need to construct the telescopes, and that brings machines, people, etc., into the radio quiet zone and makes it very tricky. External RFI, which is some of the things I normally talk about, right? Satellites or other uses of the radio spectrum outside of the radio quiet zone, producing interference into us, and how do we work on it. RFI monitoring, so we need to know what the RFI on the site is, if anything is changing or there's something new, we need to work on it. And software development for RFI mitigation. So just to start on the internal part, we work very hard on EMC and RFI compliance of our products. Right? So we make sure that every single part of the telescope that we produce is compliant to our standards. So we are very, very careful on radiated emission requirements, right? The noise that our own equipment emit. We do that through RFI EMC control plans. We do qualification testings, and we work with our site entities here in South Africa and Australia, having site permits for contractors, etc. And we have our own qualification facilities, so we have anechoic chambers and reverberation chambers where we do all the testing that each of our components need. You can imagine how many of those we have. We have around 200 antennas, or we'll have in South Africa, and around 131,000 antennas in Australia. So we have a lot of products to test. On our activities, as I was mentioning, our construction activities produce a lot of RFI. And that is, of course, challenging because we have existing telescopes on both sites that are working at the same time as we are constructing. And that's always very difficult because we need to find the balances between the science that's been done on site and how we construct the telescope. And also because we have a stage delivery of the SKA, right? So we are building these very large arrays and we are building them in parts. So we say we deploy a part of the array, and then we need to commission the array. We need to do some partial science, let's say, and we need to make sure that our construction activities don't affect that. So it's always a tricky situation. Sorry, there. Also, maintenance is very complicated from the RFI point of view, because if you imagine that we will deploy 131,000 antennas in the Australian outback, we will need to maintain that every single day. Right? So we will have to have teams on the site, moving around, trying to fix things at the same time as the telescope is working. So that's a very tricky thing that we are working on. And we would, because I was saying, yeah, we need to do observation while we do maintenance 7 days a week. Particularly on our construction RFI, mentioned this before, so we construct while we have operational telescopes. We are in constant coordination with the two site entities we have, with SARAO and CSIRO. SARAO here in South Africa, CSIRO in Australia. And we are always working, trying to minimize our RFI impact, while at the same time trying to balance how much we can impact the construction and how much we try to not impact the scientific observations in the two sites. So on external RFI, quickly, this is the external use of the radio spectrum, so mostly deal with spectrum management. What we do there, we do a lot of simulations, observations, and analysis, and we work at the national level mostly with the national entities on the protection of our radio quiet zones. So on that we work mostly at the terrestrial level, and then we work at the international level. Right? We try to see what is the international regulation of the radio spectrum. We try to protect the radio astronomy frequency bands. All right, 2 minutes, so I'll try to go faster. And we work on all these different international bodies as the ITU. We work in EU and COPWOS and some other things, and of course on the CPS, which I'm not covering, unfortunately. So on monitoring, we need to know what's going on site. And we need to understand if there are changes, if our activities are producing something, if there is someone or something that's producing new RFI. So we have flexible monitoring in the sites. We normally have different positions where we do monitoring, continuous monitoring, and we can do triangulation, and we can try to find what's producing the RFI. And we also try, of course, to control the access points to site, right? If you imagine that we are constructing the telescopes, we are having hundreds of people working on site, we try to also control the access to site. And lastly, I think we work a lot on software development for RFI mitigation. So we have in our signal chain, we include a lot of mechanisms to do RFI flagging, to try to detect RFI, that it doesn't go into our data. And we are also developing like observation planners, for example, to include satellites or airplanes. And we are trying to get satellite operators to implement some mitigations on their side. And just to finish, I wanted to acknowledge our team. So we have, as you can see here, the HQ is in Manchester. We have a few people in Manchester. We have a person in charge of the site in Mead. We have a person in charge of Low. And we have some other also working, cooperating in Low. And also we have a soonly, hopefully to be open position on an RFI analyst. So if anyone is interested, yeah, maybe you can be looking for that. And that would be it. Thank you very much for your attention.
Thank you so much, Federico. Questions for Federico?
Interaction. Can you talk a little bit about the reasons the general public should care about protecting the non-visual parts of the electromagnetic spectrum? How can we communicate to the public in a way that resonates?
Well, that's definitely a tricky one, if you ask me. The way we are trying to put it is mostly on the science part, of course, right? We try to explain what the science is about, but there are also a lot of things that we do on a day-to-day basis that depends on radio telescopes. And it's a little bit indirect, so it's tricky to explain maybe sometimes or in a short time. But for example, we use radio telescopes to detect precisely the orientation of the Earth. And that is then what is fed into our GPS positioning systems. And that's why we have an extremely accurate positioning systems. If it wasn't for this particular radio telescope, which need to be sited on Earth, so we cannot do it from space, and that's BLBI, BIGOS, BLBI for geodesy, if I'm not wrong, that's extremely important, and we depend on them on a day-to-day basis. Also, one of the things we always try to explain is that radio astronomy has a lot of spin-offs that benefited society a lot. Like, for example, the development of Wi-Fi or the techniques that are used for MRIs were developed by radio astronomers. Those are some of the things we try to put out to the public. It's a little bit tricky because it's not so simple to show radio images and explain that as simple, but we try to approach it from that side.
Richard.
Are both the sites so remote that you don't detect the signals from airplanes?
No. The answer is no. No, the sites are very remote, but it doesn't mean that there is no emissions. But what I can say, and sorry I didn't put that in here, if you see a spectrum plot from Sydney and you compare that to the spectrum in the SKA low, the difference is huge, huge. still in the SKA low, for example, radio spectrum, you can see emissions from satellites that are all the time present. So you see some parts of the spectrum with satellites, and also you see emissions from planes. We are working on both sides to try to shift a little bit the plane routes, but it's not that easy. And so we are trying on that. We are balancing between trying to move air routes on the side or trying to implement some mitigations on our side, because planes are also transient sources. So it's not like they're there all the time. So if we know when they are going over site or stuff like that, we can mitigate them.
What's your worst worry?
Worst worry.
Is it direct to cell?
There are several. I think satellites are a big worry, because what I was saying, radio quiet zones are very, very, very effective on the ground. Satellites and the proliferation of satellites makes everything much more difficult. I'm not saying that we will not be able to do radio astronomy in the next 30, 40 years. We will still be doing radio astronomy. It's just going to get much more difficult. And direct to cell and this type of activities makes it ever more difficult. So that's especially with satellites, because you cannot do it at the national level, right? You need to start interacting with other countries, directly with companies, and it makes it much more complicated.
Thank you very much, Federico.
Thank you.
That was RFI from the perspective of a square kilometer array observatory and expert. And now we will hear a corollary on RFI from the ALMA perspective. Please, Giorgio Siringo.
Good afternoon. So let's see, let's wait for the presentation. So I can start in the meanwhile. Oh, okay, here we are. So I will present the situation with RFI at the ALMA Observatory, and on behalf of the joint ALMA Observatory and Spectrum Management Office. And which one is this one? Oh. Yeah. So before talking about RFI, I would like to introduce the observatory, because not everybody knows this. And it's a global project. So in synthesis, we have practically North America, Europe, and East Asia, and the participation of Chile. And where I work is here, the JO, which is the joint ALMA Observatory, which is practically where all the three executives they overlap. And the site is in Chile, of course. We have headquarters in Santiago, and then we have two sites in the north of Chile, very north of Chile, in the Atacama Desert. And there is a site at 3,000 meters where I have my office, and the operation site at 5,000 meters. And this is a look taken from Google Maps. And you see that this is the operation site where the antennas are, where the telescopes are. And this is closest urban areas. There are San Pedro, which is very popular, is almost 50 kilometers away, and Toconao is 30 kilometers away. So the site is very well isolated. It's also 5,000 meters, so it's naturally shielded. And the government of Chile gave us a concession of land in 2003, if I'm not right, wrong, yeah. And then later on, there was the institution of what is called the Atacama Astronomical Park, which is surrounding actually the ALMA concession. So the place is started to be a little bit crowded now. There are several more observatories around, and they are mostly radio telescopes. Just to mention then, what is ALMA? Mainly it is made of three different arrays. One is made of 50 12-meter antennas, and these are movable, so that we can move it around with a transporter to change the configuration of the interferometer. And then we have a smaller array. These are not moving, unless for maintenance. There are 7-meter antennas, they are 12, so they start to compensate for the zero spacing. And then we have 4 antennas. They are used as a single dish. So we have a third array of single dish telescopes. This is the spectrum. So what is ALMA observing? So we start practically where the SKO ends. We are above the upper frequency of the SKO. We start at 35 gigahertz and we go up almost at 1 terahertz. And one thing that is important to know is that this range of frequencies, they are very much absorbed by the water vapor molecule. So practically what you see are these lines. This is the water vapor. And and these colors just give the indication of how much content of water is in the line of sight. And when the line of sight is good, like below 0.3 millimeters of water, then we can observe also close to 1 terahertz. Otherwise, it's practically impossible to do observation. That's the reason why we went in the driest desert on Earth and at 5,000 meters of elevation. Another point I want to show you is that, practically only 7% of the spectrum of ALMA is below 100 gigahertz. The most of it is above 100 gigahertz, and this is additional natural shielding because there are not so many emissions at these frequencies. Well, we recently started this GAO spectrum management office, and we coordinate activities in Chile, but also internationally, for example, collaboration with the CPS and so on. And yet we have also a group of people, the spectrum managers of the different observatories. They're working in what we call the Chanantor Plateau. And as you can see here, I'm indicating that there is a large number of telescopes. So these are in the Atacama Astronomical Park. So we are not alone. There is a lot of people around. And important to mention that the government of Chile, through the Subsecretariat for Telecommunication, gave us a quiet zone. This quiet zone is practically divided in 2 parts. There is a 30-kilometer quiet zone where it's really there's a protection zone. Emissions are forbidden. And then there is another part which is larger. It is 120 kilometers around the observatory, which is called coordination zone. So the emission has to be coordinated with us. And this is the picture of it. And as you can see, unfortunately, we are very close to the border of Bolivia and Argentina. And so this means that even the protection zone is actually not completed because the national authority doesn't have authority in Bolivia and in Argentina, of course, it's a national authority for Chile. So the quiet zone is only valid inside the Chilean territory. And this is where the agenda item 116 for the WRC 27 is very important for us to get recognition of this quiet zone internationally. Right, so to summarize, we are naturally protected. The spectrum is very high, so this is good. And Chanantor is at 5,000 meters, so from ground emissions, we are very much shielded. But of course, as I mentioned, 7% of the spectrum actually is below 100 gigahertz, so that part is more exposed. And also, as I mentioned, we are very close to the border with Bolivia and Argentina. We are not protected there in that area. And of course, there is a problem with the satellites because this is started to be a problem for ALMA as well. I have to say that so far, we don't have RFI detected in the science data. They are not produced inside the Atacama Astronomical Park. So practically the only RFI that we have, or we produce ourselves, they are self-inflicted by us, or coming from nearby observatories in the Atacama Astronomical Park for several reasons. And we try to coordinate this. But we don't have problems at the moment from ground emission from other sources. But of course, the satellites, we cannot stop them. And also the national authority doesn't have any authority. Thanks. So I divide here the effect of the satellites. One of the problems that we had in the past was the satellite called CloudSat. This is an Earth exploration service with an active radar, and it was very powerful, could destroy our receiver in band 3. So we had to park the antennas when the radar was moving in the sky, and they didn't really coordinate with us the operations. Luckily, now the new one, so CloudSat now is decommissioned, but there is a new one, which is EarthCare, and thanks to the IUCAF, they made an agreement with the European Space Agency, and so they switch off the emissions actually when they cross over the observatory. For them, it's just roughly 3 seconds, whatever, 4 seconds when they cross the ALMA site. And for us, was taking hours let's say, to park the antenna and then start again the observation. So this is the lesson learned here, that having this coordination with the authority or with the satellite operators is very important to save observing time. And also, of course, the quality of the data. And then I want to mention that with the satellite constellation, we have a problem here in the near future, because they are planning to use these frequencies. So there is a band 37.542, which is band 1, ALMA band 1. There will be 7176, it will be ALMA band 2. And also, this is Starlink, and this is AST, Space Mobile. They also have plans for this. And then there is SpaceX made an application at the ITU to use these other frequencies, which are actually above 100 gigahertz. So they are planning to use this range of frequencies that will cover band 4 and band 5 of ALMA. So this is really a problem for us. And these are downlinks to the gateway stations. This is not for user terminals. So if they start to do the direct to cell, someone was talking about direct to cell, right? And they will have millions of users. And so they will need high bandwidth to transfer the data. And so they definitely will put more gateway stations even in Chile. And I hope they don't put it too close to ALMA. At the moment, the closest one is at 500 kilometers. And I think, okay, last one. This is something I'm planning to do. So I've already started this program to do monitoring. This is a plot that I found in this paper. It's very interesting because it shows what is the speed of the satellite, in the angular speed, apparent angular speed when they move in the sky, depending on the angle of the observation and the distance. So there are some satellites in the LEO area. There are some of them, they are much closer, let's say below 500 kilometers, some other are more far away. So our telescopes, luckily, they are so fast that they can go up to 4 degrees per second. So we can track the satellites with the ALMA antennas. So this is what I'm going to do. I am already started this plan for monitoring, because I don't trust very much the satellite operators. So I want to be sure that they are not really emitting in this area. And so we start to make a database of emissions, and then we keep monitoring to see if there is change at some point. I believe that at the moment they don't have any reason to do these emissions when they cross over Chile, but or let's say over ALMA, but you never know. So we have to monitor this because the situation is changing definitely in the near future. And that's it. That's my last.
Thank you, Giorgio.
Thank you.
One question and then we'll move on.
Thank you very much. Thank you really for that great presentation. I have one question. So when it's optical observation, you can like quote a satellite black or something, to the dismay of thermal engineers, by the way, and you can avoid like some sort of, you can at least diminish, it's not effective, but diminish the amount of effect the satellite have on observation. But how can you mitigate in terms of RFI?
There is no way. So if the emission is there, that it will affect the data. What we are doing at the moment, actually in collaboration with SpaceX, this was started by the National Radiodynamic Zone of the NRO in the US. They started a collaboration doing something that's called boresight avoidance. So practically when the satellites, they cross over the telescope, they switch off the emission in the frequency that they know that the telescope is observing. So practically there is a server in internet where the observatory is providing this information. And so the satellite operator knows where the telescope is looking at. And so they know which satellite are crossing in the boresight and then in the main beam of the antenna. And they know the frequency. So they can switch to different frequency in that moment. I say it again, for them, it's a matter of a few seconds, even less than a second when it crosses through the boresight of the radio telescope, because they are very fast in the sky, and then the angle of view is relatively small. And for us, trying to mitigate this and move the telescope, it takes several minutes, or even can take hours to park the antennas and then recover the whole system. So this is a very nice way to do. So if the satellite operator is willing to do, but it's on the side. So if they don't want to do it, or maybe they do this now and then maybe next year they don't do this anymore. So, and also this is only SpaceX. So we don't know what will happen with the other satellite operators. So the situation is a bit unpredictable, I would say, at the moment. I hope this answers your question.
Thank you again, Giorgio. Next, I'd like to invite Nalini Hir-Alal-Isor to the podium to tell us about the Mauritius Radio Telescope and
threats to both the radio and the optical at that site. Nalini.
This is to move forward. Yeah. Okay, it seems to be a little bit distorted from what I had in this PowerPoint. So thank you for this opportunity that I'm having to present on the probable need for preserving the site for both radio and astronomical observations. This is just the abstract. So for those of you who probably do not know where Mauritius is, this is the red region here, that red small island. So it's really tiny, less than 2,000 square kilometer, but still has 1.3 million inhabitants, which makes that it is one of the most densely populated countries in the world. So you expect, obviously, with the kind of technology people use nowadays, we are obviously very difficult to get some place which is really quiet, radio quiet and really dark. But still, the Mauritius Radio Telescope site, this is an example of, this is a Google map of the site. The center of our array is here. And we have this 2 kilometer by 1 kilometer extent. It is not far from the sea and it looks pretty green. So it is relatively remote for a place like Mauritius. So, how was that site? How did we enter the world of radio astronomy from a small country like Mauritius? Well, basically, this was due to our collaboration with a much bigger country like India. So it was an Indo-Mauritian venture dating from the 1990s. And as you can see, we have had an array of helical antenna to observe the radio sky at 150 megahertz. So the two flags of the two countries here. And this is part of an aerial view of part of the array extending over 2 kilometers in the east-west and nearly 1 kilometer along the south. And I think that was one of the first interferometric array on the African continent. Well, we're not really on the continent, but anyway. So this did real astronomical observation. For example, it was also equipped with pulsar, It was also equipped with a pulsar receiver. I myself use it to observe a millisecond pulsar. And my other colleagues also observed other parts. And the three of us were also involved in the setting up of the whole infrastructure for this facility, and as well as use it for our respective PhD work with the help of scientists from India. So with all that, and very unfortunately, there has been a sort of downfall for that place. We have limited economy, small place and limited people. And I won't have time to go over the details, but more specifically, since 2006, we have started having a big system degradation and people stealing cables just for the copper. And then the technical staff to repair things that were going down were not replaced, and less people coming from India, technical staff to help out. So ultimately, the sad thing is that in 2001, the Mauritius Radio Telescope as such was decommissioned. So, but what next? As you know, the Mauritius, around the same time, 2006,
almost at the same time, we were also became one of the partner countries with South Africa in the SKA project. So, and, but meantime, even before anything happened with respect to that, the whole facility, the infrastructure developed there has been used and is still in use for some other activities like solar activity monitoring, solar radiation measurements, etc., and as well as some outreach and stargazing thing. And obviously, activities which will help us prepare to host an SK site in Mauritius. We don't know exactly when that is going to come, but we are sort of preparing. And in particular, since 2019, we have been having DARA-funded research students at the University of Mauritius. I am in charge of that project. And we have also been consolidating astrophysics and radio astronomy within our syllabus. So this is just a glimpse of the kind of outreach that can happen. That was a major solar eclipse, and it was not even planned. Policemen coming to line up to observe the eclipse, and even the transit of Venus was a major event. And this is daytime, and nighttime. That was a one of the many stargazing nights we have had there, always successful, with very limited equipment, very small telescopes, as you can see, nothing like professional grade optical telescopes. And that one was an event by the DARA students. Yes, and yeah, I will, just for those who are interested, what kind of work they have done. So, and there are some of my students who are here. There were 6 students who joined, and they have been setting up some an array with small dishes at the telescope, at the telescope site. So that this is an ongoing work. They are still working on it. And so what is the outlook regarding the future? We need to take stock of our strengths, weaknesses, opportunities, and the threats. Of course, one of the strengths is we have that location. It is in a small place. We cannot really be too choosy because the space is limited. We can't have the kind of sophisticated, really dark thing, but it is relatively dark compared to other places. We have some problems, and we have opportunities with the SK. And one of the threats is also the our operational structure and possibly a dark sky degradation if we don't take action. So we hope that we are going to convert this place, it's no more Mauritius Radio Telescope, but maybe call it the Mauritius Astronomical Observatory or some other name, to host a variety of installations and be used for both to complement our teaching in the field and also engage in outreach and astrotourism. You might have seen that we have even a center near it, a visitors center, and some hotels. Maybe take them on board, get some money with this, and also make them conscious of the need to preserve the site. And of course, that is something we need to do home to restructure it properly and get the proper collaboration. So, and what I hope that with the people in the audience here, that we can get some kind of support or encouragement to be able to attract the attention of authorities for the need to preserve that site, because it's a small place. This is all we have, and we have to maintain it. So, and so thank you, and any support will be much appreciated.
Thank you so much, Nalini. Questions for Nalini? I have a quick question. What has so far been the receptiveness of your government to your pleas for protection?
Yes. So I must say that this telescope falls under the University of Mauritius. It is on state land, but it falls under the University of Mauritius. And currently, things are looking as if we are going to get some support from the new dean of the faculty. But personally, I think our structure is very wrong. We cannot be under a department of physics, under the faculty. Too many hurdles on the way. We should have a more direct thing and a more direct support from the ministry. And I believe if we have something, maybe written, something like that, we're not talking about financial support, it can help for us to attract attention of government, I think.
Good luck. Thank you so much, Nalini.
Yes.
Thank you. When you go out tonight, the weather is forecast to be clear. Look up and look at the moon, and realize that astronomy is moving to the moon. And we'll hear a couple of talks now. First from Julia Josha about the role of astronomy in regulating the moon's environment.
Yes, good afternoon, and thanks a lot to the organizers for giving me this opportunity to present this view on moon issues from the perspective of radio astronomy. So we have heard about interference at our terrestrial telescopes, and this is an ever-increasing problem. We know that, and this is why wise people long ago have already thought about how it would be to actually put our telescopes on the far side of the moon, shielded side of the moon, where they are protected. And this has actually been addressed, as I said, quite long ago, and it's already represented or already reflected in the so-called radio regulations. And I have to introduce this international treaty to you. So this is maintained by the International Telecommunication Union, radio communication, and it contains definitions, rules defining the services, including radio astronomy service as one of them, and also a frequency allocation table. It's changed once every 3 to 4 years. Next time this will be 2027 at the so-called World Radio Communication Conferences, where you can actually make the changes to this regulatory treaty. And the ITUR is also responsible for so-called reports and recommendations, so guidelines on how to interpret the radio regulation and how to harmonize the services, radio services amongst each other. And this is done by work in study groups or working groups. And the astronomers, like me, we participate in these at the ITU level for astronomers. So now, yeah, the shielded zone of the moon is extremely well protected. It's a region that enjoys protection like no other region anywhere reachable by human beings. The sources is the radio regulations and a recommendation describing how it should be protected, and other recommendations by reference that I will discuss partly. But the field is evolving. We know that there is a space race to the moon. There might be some valuable minerals that are available on the moon. So suddenly, spectrum on the moon has also become a resource that has become extremely interesting for users of or for participants in the space race towards the moon. So from an astronomical point of view, this protection is required to be sustained and harmonized. We need to participate in this process of allocations if we want to sustain our possibility to do our beautiful astronomy in the shielded zone of the moon. Shielded zone of the moon is also defined in the radio regulation as the cone that you see here. Sorry, go back here. That you see here. It's not only the surface of the moon, but also this cone on the far side of the moon, as seen from a sphere with a radius of 100,000 kilometers from the center of the Earth. So one remark with regards to the optical astronomy and multi-messenger astronomy that is currently not very well represented at a treaty level. And I think Richard will talk about that later on. So paragraphs 2222 to 2225 define protection in the shielded zone of the moon, and it says that no radio emission, active emission is allowed. Wonderful, right? But there are exceptions. And as I said, this is really the most comprehensive protection that radio astronomy has anywhere. But the exceptions, there we have to, of course, allow space research service using active sensors, whatever that is. So this has a broad definition. And in the context of supporting space research, also communications and operation. Of course, we have to get there. We have even to put our radio telescopes there, and they need to be able to communicate. There is Earth exploration satellite service, including also radar, Earth penetrating radar, that is to be allowed, and radio location service. So this is a harmonization process that we need to follow, and that needs to be coordinated with the other services. And this is how it looks like. So this is, I think, credit by Kathy Shem and NASA. So this is how communication can look like. You need to get to the moon. You need to get communication between the relay stations, then between the vehicles and stations on the moon. So this can be really, really complicated, and all this is then has to be covered in communications and coordinated with radio astronomy. Then our position right now is reflected in the preliminary guidelines of recommendation RA 479. Here, astronomers point out the following thing. First, the atmosphere is opaque at very low frequencies. Then at also low frequencies, many frequencies are already occupied on Earth, which would then require to be protected on the moon. So the recommendation is basically limit the emissions to a band between 2 and 3 gigahertz, and another band of 1 gigahertz wide to be identified. I need to hurry up. Currently, what's going on, what we need to protect currently are mostly experiments at a very low frequency range, let's say with a max of 200 megahertz. But of course, we need to take care of future generations that want maybe to put an SKA or an ALMA onto the moon because they want to profit from missing atmosphere and, of course, missing communications. A special worry is UMR. So your average radio noise coming from any transmitter not only transmitters, but also other electric apparatus. That also needs to be addressed on the moon, and luckily this will be addressed in the new upcoming agenda item. At least it is mentioned, first time at the ITU level. I think I'll just leave you with the summary, and I hope I could give you an overview of how radio astronomy is engaged in protecting well, astronomy on the moon. And thank you.
Thanks, Eula. Questions for Eula? Yes.
So when are we likely to have astronomy on the moon?
Oh, it has already started several years ago. There were test antennas on the moon by a Chinese-Dutch mission, and currently there's also a US mission that has landed on the moon. So this has already started, and there are pretty concrete plans to follow up.
First, I'm glad to see that irons will be banned on the moon, so I can just look wrinkled when I get to go there. So that's good news. This is at the limits of what I understand, but I am curious of your perspective. I understand that there's the Lunar Treaty that not everyone signed, and there's the Artemis Accords, and people are kind of breaking up into national blocks. So how do you think that will affect the ability to protect this comprehensively and play into the discussions at the ITU?
So Moon Treaty does, of course, affect astronomy. So we need to protect and respect each other on the moon. But at ITU level, I think it is much more important to stick to the current regulations that are given by the radio regulations, as I pointed out. Richard will follow up on this because the Moon Treaty is much more important in the context of optical astronomy and multi-messenger astronomy. I hope you agree, Richard. Yep.
So thank you for this really interesting presentation. I'm just wondering, and excuse me if it sounds a bit naive, how actually does radio astronomy on the moon complement and interact with what we're now capable of doing in terms of, and of course we won't have problems with satellites and things like that, hopefully, but how does it complement the radio astronomy that we're able to do both in space and on the ground from the Earth? Or is that relevant for you?
Yeah, of course. This is definitely relevant. If I may just go back to this slide. As I said, these are experiments that address very low frequency aspects of radio astronomy. And this is an example of what is not possible on Earth, simply because of ionospheric reflection of radio waves either way from space and from Earth below, let's say, 10 megahertz. So these are basically the low-hanging fruit that we want to grab these days. But of course, I mean, there's also other atmospheric windows. I mean, you need to have large telescopes for this. You can build them in space, and they should not be affected by RFI, which is easily done by other satellites. So you need to build them somewhere special, and that's certainly one complementary application. There are more. As I said, they are laid out in this recommendation 479. And well, we can have a look at the details of this. Basically, astronomy below 2002 gigahertz. That is basically what can be done in a very complementary way, but also at higher frequencies, of course.
Eula, we have a question online. Can you answer very quickly from Mike Peel? how long do you anticipate it will be until a private company establishes or tries to establish a satellite constellation around the moon?
So I think this can be very fast. I don't know. Actually, I don't know. Maybe someone in the audience knows this better.
Not yet. All right.
But I mean, space race is on. Artemis tries to involve private companies, and there are private companies that are highly interested in moon missions. So I expect that this may happen pretty quickly, within a decade or so. Thank you.
Thanks, Eula. Thank you very much. This session is the session of the Working Group on Dark and Quiet Skies at the Executive Committee level of the IAU. That is one of two bodies devoted to Dark and Quiet Skies. The other one is Commission B7, that's jointly within Division B and Division C. Within that Commission B7, there is a working group devoted to protecting the environment of the moon from radio interference, from light pollution, from any interference with astronomy on the moon. That's the general topic. And Richard Green leads that working group. And please tell us about it, Richard.
And remembering that the charge of Commission B7 is protection of existing and potential astronomical observing sites. So it's right within the purview of this working group and the associated commission. So that's why why Josh and I are talking to you about the moon today. And we are fortunate in that we need a broad range of expertise to address this problem, because we want the instrument PIs who have funded and aspirational plans to build facilities long-term. We have our spectrum managers. You've heard from two of them today. We have agency advisors, and we have a whole cadre of folks who aren't necessarily IAU members, but are experts in space policy and space law, so that we can go and address some of the issues I want to talk about. So why the moon turns out to be a unique observing platform that cannot be duplicated on Earth or in orbit for several problems for a long-term build out. So it's not going to happen tomorrow, but on a 20, 30, 50-year time scale, we want to be able to do these astronomy problems. So why is Josh fighting so hard for this radio protected zone? Well, it turns out that there is this period of cosmic time called the Dark Ages, when before stars, galaxies, black holes formed, and the only detection you can make is from the neutral gas that is starting to clump up and make itself into little structures. And so the search is for a tiny absorption feature in the 21 centimeter line of hydrogen at somewhere between redshift 50 and 70. So you're looking in the megahertz range against the roaring foreground of our Milky Way for a very faint signal. So you need that zone free of other sources of noise. And it turns out if you build out the aspirational radio arrays of dipoles, you'll be able to detect the magnetic activity of exoplanets. So because they also, Jupiter sort of radiates in those radio ranges. The challenge is it needs a big dipole array. We're talking 50, 100 kilometers of spooling wire. And there are only, in that shielded zone, there are only 3 some planes that are large enough that aren't looking at the galactic center that's like a blast furnace. And so there are very special sites that we need for those special radio telescopes there's a beautiful high-level legal framework for how you operate in space, but there's no actual set of rules to say, we wish to designate a site for science so you don't land your rocket there or dig your mine there. And that's what we want to talk about. So similarly, there are wonderful, you would like to do coronagraphic. We've seen wonderful science talks about the world of exoplanets. We want to measure the atmosphere of Earth 2.0 and find it changed by biological processes. So there are cold traps, there are craters near the lunar poles that have not seen sunshine for approximately 4 billion years. So they are really cold. That is to say, if you set up a large aperture telescope in there, it will be colder than James Webb Space Telescope and will start right to work in the area of the thermal infrared. You can envision an interferometric array that you could spread over tens of kilometers, because the surface vacuum of the moon is 10 times better than what LIGO has ever pulled in a tube. And so this is a lab that excites us, if only we had the funds and the foresight to go there. So that's why I'm saying we're looking long term here. The challenge of those craters is that they have water ice, and water ice is the key to human habitation, to the development of fuel to use the moon as a spaceport for exploration of the rest of the solar system. And so that real estate will be hotly contested. Again, we want some rules of the road to be able to designate sites for specific uses. And finally, I'll just note that the moon is a superb gravitational wave detector. It has sensitivity in the overlap range between the Earth-based LIGO, Virgo, CAGRA frequencies and what LISA intends to do at very low frequency. This hits one right in between. The moon is so seismically quiet that they haven't even gotten the baseline for what they're having to detect against in terms, and you can pop a laser across a crater, or you can go into one of those cold traps and have an array of cryogenically cooled seismometers and have sensitivity beyond what the current Earth gravitational wave detectors can do. So the moon is a coveted observing site, but it is also a site for national exploration, for human habitation, and a spaceport. So, and mining opportunity, I guess I'd say. So these are incompatibilities. Josh told you, low frequency noise is not consistent with a radio quiet zone. If they don't start paving the landing sites real soon now and develop a real spaceport, every time a spacecraft lands and takes off, it kicks dust into low orbit around the moon, much less particles that will dust your telescope mirror. And mining is mining. Once you start slamming a shovel into the ground, the moon will no longer be as seismically quiet. So there are conflicts that need to be resolved and designating sites. So our immediate goals of this working group is, first of all, the decadal survey does not broadcast these opportunities yet. So reminding the astronomical world of this potential is important. All these projects have to start sensitivity modeling. How far away can my steam shovel be working on the moon before it seismically is damped enough that it hasn't induced a big noise floor, for example? What kind of concentration of aerosols is tolerable so I can clean my IR mirror every once in a while? Those it's early days for concepts, and so I haven't thought at that level of operations, but we need to soon. We are not alone as astronomers in wanting to exploit the moon for science. So I've made sure that we've made good connections with what's called the Moon Village Association, who has a working group that has devised most of the white papers about science on the moon. All our colleagues who like the geology in quotes and primordial composition studies of the ices and the lava tubes are in COSPAR. And so we meet with them regularly. And then there are two astronautical federations, because we want the developers who are getting the lunar villages complexes going to remind them they need to shield their electronics. And so there are a lot of alliances that IAU has made with the groups that are active in wanting to support science on the lunar surface. Ultimately, this is a UN story because it's an international space race right now. It's the US, it's Europe, it's India, it's China, Japan. There are a lot of countries, Russia. There are a lot of countries that have gone and wish to go to the moon. And so the way you make international ground rules is through the UN. And we've got a surprise boost in that the science committees of the UN have agreed to set up an action team to start addressing issues, at least of communication and ultimately of coordination, which will be great. You asked about Artemis and the Moon Treaty. The Moon Treaty was terrific. Nobody signed it, but they had a mechanism for setting up science preserves. The Artemis Accords do not. They wish to exploit the moon. So they have a technique where you can declare a safety zone, meaning I'm going to operate with this radius and do bad things, and you've got to stay out. So if we can find a way of inverting that matrix and saying, we would like you to keep out of that zone because it needs to be very quiet, maybe we can work within the Artemis Accords framework. However, Russia and China have not and will not sign that. And so to get unanimous agreement on anything, it has to be broader than Artemis. I'll throw this out because this is more general than the moon, but it matters for the moon. You know, what is ethical conduct of research in space? That is, and so the principle of the Outer Space Treaty is that you can't appropriate an asset for exclusive use, which means that, you know, China may have a plan to build, they do have a plan to build a telescope on the moon very soon, but it's inconsistent with the Outer Space Treaty that only their scientists could use it. So how do we realize that in point of fact? You know, is there a competition process to say who should have this exclusive site? Should there be an open competition to make the instrument? Is it sufficient to just have open data? We as an astronomical community have to get together and say, how is the way we conduct our scientific business consistent with the principles of the Outer Space Treaty? And so we need to help our spectrum manager colleagues at the ITU. We need to get COPUOS to start thinking long-term about preserving those sites. And we're trying to get wide recognition that the time is now to preserve a 30 to 50 year strategic direction for the coexistence of what internationally is regarded as equal priority activities of science, of human activity, of mining. All those things are viewed equally in the eyes of international law, but we got to set up the ground rules now. So that's my talk.
I'm glad you ended on the ethics slide. For me, Richard, there's something that kind of makes me vaguely and somewhere between vaguely and deeply uncomfortable about all this. It feels like we have seen this and done this before. We've assumed that there's Terra Nova out there, and we just need to figure out how to allocate it all. And we've seen that mistake play out time and time again to the point we're trying to recover it. So I'm interested whether there's been any discussion in the sense of starting with allocating places maybe for the moon and then figuring out how we can work around that, for whatever that means, as opposed to let's take today's science and use that cold place and put it over here, and then who knows what we're going to know in 50 years or 100 years. And we have some hindsight here. So again, just curious, have there been discussions at that sort of ethical level? Or is it just, there's a blank body there, we just need to figure out how to allocate it fairly equally between anyone who happens to get there?
that would be an ideal world in which we wish the UN would operate. But we're really building bottom up with, it is truly a space race and competition right now. And so I have not, the discussions are at the UN level are astonishingly low level. That is to say, they're debating if somebody is doing something that they shouldn't be doing, should they be telling us? And the answer is, well, yeah, if they're going to land right next to you, even if they're not supposed to, it'd be better if you knew than if you didn't. So they're not anywhere close to thinking globally about the best deployment over the whole moon. But the step that we want them to take is to say, here are all these competing activities. We have to have a way of at least rationalizing them so two countries don't go to war over stepping on each other in that remote location. So do we have the foresight to know what science we want to do in 50 years? We don't. But for sure, if we don't reserve something now, we won't have any opportunity. So setting up this process to say what's consistent with non-appropriation and still allows the possibility of international science, we have these more modest goals, I think.
Yes.
Thank you, Richard, for all these issues. Have you considered the effect of military presence on the moon? For instance, we know people from Tucson know the light pollution that comes from Davis-Monthan Air Base. It's going to be there.
So let me rephrase your question. Where do we draw the line on dual use? The military wants to be extremely well informed about what all other countries are doing everywhere. And so, and that's everybody's militaries. And so they will want to be monitoring, to be observing, to understand the presence and intention of every other country's actions on the moon. And they will ask their governments to push the boundaries of the Outer Space Treaty, which prohibits direct military kind of activities on that. So all we can do is work through the diplomatic sides of world governments to say, you're a signatory to this treaty. It says no military activity. And so let's try to push back on that line and make sure it's actual peaceful uses. By the way, the irony of all that, of course, is that the Russians are the most vigorous objectors to satellite constellations that have dual use because they can inform the military about ground-based activity in war zones. And they said, this is not reasonable. This is an infringement on our national rights. So that pushes in multiple ways, and the moon's going to be even more complicated as a venue.
Thank you very much, Richard. We have one more talk in the session, which will pull together some of the numerous threads in the incredibly diverse set of talks we've already heard today. Now presenting will be Mathieu Renaud, who will speak on light pollution, a complex real-world problem to be tackled through exactly what many of us are calling for, an interdisciplinary approach.
Thank you very much. I will actually not speak too much because we have a record made by Samuel Chalea, who is the national coordinator of the so-called NEO. So it has nothing to do with near-Earth objects. That's the name for the kind of interdisciplinary device we have in France. And so he is online, I suppose, and he has recorded this 8-minute 38-second of a video. So we are like good in time. And I'm here in person, so you have no excuse for not asking questions. We are everywhere. Okay, we can go if you want. Thank you.
Good afternoon, everyone, and first of all, thank you to the organizer for allowing us to give a talk on light pollution, a complex real-world problem to be tackled through an interdisciplinary approach at this International Astronomical Union General Assembly. This talk is given by an environmental geographer and an astrophysicist on behalf of the members of the Nocturnal Environment Observatory, a radically interdisciplinary device developed within the French National Center for Scientific Research. First, let's take a look back at the emergence of the light pollution problem in academia and see which disciplines have shaped what we might call the ALAN problem. You certainly know about it. The issue emerged as a scientific concern by the astronomers in the early 70s, following the historic mobilizations in Flagstaff and Tucson, Arizona, as illustrated by the founding article by Basel and Riegel, both in Science. A tipping point is clearly visible on the flowchart at the beginning of 2010, where we can see the very strong growth and place taken by the natural sciences and the health sciences. Finally, in the last 10 years or so, with the first forms of landing the problem in territorial action, social sciences and territorial sciences came into play, but only very marginally. As for truly interdisciplinary approaches, they remain practically non-existent. Through their respective work, each of the disciplines that make up what we call light pollution studies contributes to the construction and existence of the benefits and needs of darkness in the scientific debate. Doing so, they relegate ALAN to the status of a new anthropogenic pressure whose magnitude needs to be measured and whose effects need to be understood. These light pollution studies take up the counterpoint to other approaches historically more concerned with territorial issues, particularly in the urban territories of the so-called economically developed countries. For these disciplines, which form what we call urban lighting studies, ALAN is an essential planning tool for the benefits that it brings in terms of comfort, safety, and development. Put schematically, the disciplines that make up urban lighting studies look askance at light pollution studies, which calls into question our many uses of artificial light, an object that was long considered to be exclusively positive. Because of this fundamental opposition and the object that links them, these two large multidisciplinary blocks are still struggling to dialogue. However, when it comes to solving the situated and place-based problems raised by ALAN, we need to think jointly about the social, technical, ecological and health issues involved in the lighting-darkness couple. In order to work at this interface, we have mobilized over the last 10 years a new research object, the nocturnal environment. We make this boundary object the container of global issues of experiential relationships with nature, of biodiversity protection, public health and energy transition. Through this lens, we understand that reconciling the different meanings of the nocturnal environment is becoming a global problem of equal interest to naturalists and urban planners, as illustrated by the cover of a recent thematic issue of Science. This reconciliation requires the construction of land-use compromises based on consideration, deliberation and arbitration between, on the one hand, the human needs of ALAN and, on the other, the human and non-human needs of darkness. Considered in this way, the nocturnal environment object allows research to be fully rooted in the holistic framework of socio-ecological systems. By definition, the study of socio-ecological systems cannot be purely technical, purely social, or purely environmental. It requires the production of knowledge that is both inclusive and situated, and therefore requires interdisciplinary and participatory approaches to integrate diverse knowledge systems in order to work towards a place-based resolution of this problem. In order to enable, facilitate and organize this interdisciplinary and this multifaceted issue, we created in 2021 the NEO, which stands for the Nocturnal Environment Observatory. It gathers 23 members from various fields: territorial and social sciences, natural sciences, sciences of the universe, and engineering and environmental physics. We let you read our 3 interconnected main working areas, all teed up together around the nocturnal environment, our focal object. Our pluridisciplinary team has been carried out projects on several French territories, schematically ranked in 3 types: several environmental protection areas, rural and urban ordinary spaces, and larger territorial units which we define as workshop areas such as Réunion Island. La Réunion is a French overseas department, a volcanic and tropical island in the Indian Ocean, a world biodiversity hotspot, host of a national park with several environmental protection initiatives. As you can see on the map to the right, the island is experiencing a strong urbanization process, moving up the island's slopes and putting this territory under island pressure. Here, the topic of light pollution has been addressed for some 15 years, but almost exclusively through a monodisciplinary approach focused on nocturnal avifauna. Our first exploration studies have put forward the existence of lively cultural relationships and related practices to darkness, all of them being enclosed in the term of fait noir in Réunionnais Creole. Fait noir has been shown to be a soundscape in its own right, shaping particular experiential relationships with the nocturnal environment. From what the inhabitants can tell about their everyday life nocturnal soundscapes, we have hypothesized that one could better grasp the radical evolution of the living spaces at night due to, for example, lighting, changes in outdoor nightlife practices, urbanization and environmental transformations, loss of biodiversity, and so on. We therefore set up a research program supported by the MITI, the transdisciplinary mission of the CNRS. This program consisted in setting up participatory workshops with inhabitants from different living spaces to explore their nocturnal soundscapes, combining social approaches to the nocturnal environment with natural sciences, in particular ecoacoustics. Each workshop has been carried out in 4 steps. The first step is to meet the volunteer participants, explain the methodology, and distribute pre-programmed acoustic recorders for installation in their daily outdoor spaces. The second step is to retrieve the recorders and to conduct an in-situ ecological and landscape diagnosis at each participant's place. The third step is to pre-process the ecoacoustic data using artificial intelligence to detect and classify sound events. This step allows us to dissociate, visualize, and map the main categories of objective nocturnal soundscapes. Finally, the last step takes the form of a game about the collected nocturnal soundscapes. For the participants, the goal is to listen to their soundscapes and make them speak in order to answer some fundamental questions. For the research team, this is an essential step in initiating collective debates about the perception and interpretation of nocturnal soundscapes and their recent evolution. In other words, our goal is to better understand how people know and experience their nocturnal environment through a lens other than Alan. Such workshops, which have been held on several occasions over the last 2 years, have led La Réunion National Park to embrace our framework of a socio-ecosystemic approach to the nocturnal environment. In particular, specific training of the national park staff has been provided, and an event program running throughout the years named Les Jours de la Nuit, the Days of the Night, has been built around the different approaches related to the nocturnal environment. Through this case study in La Réunion, which presents only a small part of NEO's work, we hope to have sparked your interest in using interdisciplinary approaches to tackle the challenges of preserving the nocturnal environment. Thank you for your attention, and we'll be happy to answer any questions you may have.
Thank you so much for this fascinating presentation about this fascinating institute and the complexity that you've described so nicely. I want to suggest that because we have only 6 minutes left in the session, that we gear our questions in the next 6 minutes towards general discussion with an eye towards the interdisciplinary perspective that we've just heard. So questions and comments before we break at 3 for another half hour, please.
Thank you very much. Speaking of interdisciplinary fields in protecting the night sky, wouldn't you assume like involving policy and lawmakers is also, one important aspect? Because in our country, at least, like the government has taken a role in beautifying the cities, and most of the thing that they do is like they use these beautiful lights that are, cool to look at, but they really pollute the night sky. So if we take it into the policy level and convince the lawmakers, we have space law in our country, and if we integrate it into that field, into that area, wouldn't that be a lot more helpful?
Yep, completely. So far, we have been working on those like participatory workshops with like inhabitants, but through them, we have been able to reach some of those policymakers, which are also inhabitants where we have had all of those workshops. So indirectly, the policymakers are first also inhabitants, which we can reach. And in the city where I'm living, that's the case. But you are right, it's not like entirely devoted. I mean, our action is not like really like 100% devoted to touch to the policymakers. But that's a good point. Also, through the national park, that's one step now, which allows us to speak with those people, because the national park has a kind of a larger influence than us. So, but what you said is correct. We have to touch them, because they can do like switch on and off whenever they want. Yeah.
I have a related question. To what degree does this interdisciplinary approach, as opposed to, say, strictly an environmental or human health or astronomical approach, play a role in France's national decree about light pollution and in the discussion for extending that?
So maybe Samuel, if you are online, because I know that he knows much better than anyone else the situation also at the national level.
Yes, thank you for your question. It's really in France we already have a solid legislative package on the subject, but it's a big step from law to implementation. We are working hard with this research program to get us over that hurdle. Perhaps one thing we believe to be essential in our work with local residents and stakeholders in territorial governance is that environmental public policies and decisions about light pollution control should not be imposed on the basis of just scientific authority alone. In other words, we are working to empower the public on the airline issue, because solutions to reduce light pollution almost systematically involve profound changes in people's daily use of and relationship with nocturnal spaces. The issue at stake here is one of territorial democracy, we believe. And this reasoning applies to many issues other than those posed by the management of light pollution. So I think this democratic challenge is what we call the territorialization of public policies to fight light pollution. This framework of the territorialization comes from political science, but to put it very simply, it's all about working to ensure that public policies are in line with the cultural, geographical, historical, economic, and ecological realities of a given territory. And to achieve this, we need to explore the thickness of territories. And this research can only be done, on the one hand, with the help of interdisciplinarity, and on the other hand, without excluding the people who are primarily concerned, the local inhabitants. It's very important for us to work at this interface between public policies and territorial action.
Question from Deborah.
But definitely, our approach is somehow a kind of a counter approach compared to what French Ministry of Ecology may think of how to organize the all of those questions regarding like preservation in general, which is usually the top
down, yeah,
rather than bottom up. So we are struggling a little bit.
Thank you. And another question from Deb.
So I'm just wondering, thank you for this really fascinating talk and project. I'm just wondering if you're working with universities in particular. Usually like you have the environmental department and the biology department and the astronomy department over there. And so I'm just wondering if there are any programs that you've developed or are working with any universities to work at this interface, this really interdisciplinary interface.
Yep. Among the 23 of us, most of us are part of the universities in our home cities. So I'm somehow affiliated to the University of La Réunion, indirectly, say. Same holds for Samuel and all the other colleagues. So indeed, through our own universities, we may, that ease the possibility to have those interdisciplinary projects. So yes, the answer is yes.
I want to ask one last question before we wrap up. When is the next conference that all of us should keep on our mind that we can organize together, or that is already being organized, that is interdisciplinary on ALAN and on the nocturnal environment in the ways you've described?
When you said what? When do we
Yes,
organize one?
Yes, yes.
Whenever you want, we're
Yes.
ready for that.
Okay, good, good. John, it's very quick.
Yes, I would just say that's the Artificial Light at Night.
Yep, just for
That's
the
Artificial Light at Night 2025, which will be held in October of next year in County Mayo, Ireland.
All right.
Thank you so much. Thank you,
That might
everybody.
be
We'll now
the
adjourn
place.
for half an hour and then resume for our final session of the day, the week, the year, and the next 3 years. See you in 30 minutes.
Hello everyone, I'm Exodus, Urban Light Pollutions from the Artificial Light at Nights. And also we wish to promote public science and dark sky awareness. So fans and also that affecting with some features and in order to use, which is with thank you everyone. And if you have any questions, please feel free to email me for more information.
Have people take their seats, that would be really wonderful. Okay, as you're trying to take your seats, I will just do a little bit of a prelude. We are starting off with a very wonderful talk on stewardship of the environment, and then heritage of the skies, basically, for both science and society. And then we're going to go into 2 talks that deal with dark sky places, and then 2 more talks that deal with astrodourism. So we're going to get a really good coverage of all these various aspects that are related to cultural heritages. And then we end with a pretty much an astronomical education talk that is integrated with all these things as well. And it's funny because we start in the US, we go to New Zealand, we go back to the US, we go back to New Zealand, and then we end up in Thailand, and then we end up in China. So it's like in the Asia area mostly, except for the United States. You could ignore the United States. So anyways, no. We're going to start with then Ruskin coming up here to talk about stewardship of the environment and heritage of the skies for science and humanity. So, oh, I'm sorry. Yeah. Okay, come on over.
And I know that it can get a little much in here. Connie, I might just borrow your mic. Is it on? People, yeah, I can hear myself. And the green button advances? Yes. Okay. Well, good afternoon, everyone. Thanks for hanging in there for the last session of the last day of this wonderful conference, 2 weeks. It's wonderful to be here with all of you. A joy and a privilege to share something we've been building for 15 months. I want to begin by offering our deep respects to the San, Khoi, and other indigenous communities of Cape Town and the Northern Cape. We honor their timeless connection to the land and skies, their past and present cultures, traditions, and amazing contributions. And we invite their ancestors and descendants into collaboration with us as we advocate together for dark and quiet skies. In building a natural darkness action network, which Ruskin will share more about, we had a few things in mind. Some of us are astronomers and we love studying ancient objects. I myself don't study anything after cosmic age of 1 billion years old. But we also wanted to draw attention to our ancient relationship with the skies. So as we collaborate together to defend dark and quiet skies, we are accountable not only to future scientists, but future artists, songwriters, storytellers, and cultural sky practitioners. We want to coalesce around a message that's not everything that's going wrong and what we're against, but something that we are for. And again, we want to invite creativity, collaboration, and awe, AWE, not AWW, but there's some of that too with the night skies. So this is the wonderful team of people. This was our last Zoom meeting in the summer, right before this conference. The list of names and affiliations or other countries they're based in are listed there, and most of them are represented here in this last Zoom call. I also want to take a minute to thank our team of advocacy and campaign strategists. When we began to think about this, there were so many directions it could have gone because, as you know, there are so many issues, so many topics. But as we got deeper into it, we realized that space invites our integrative, interdisciplinary selves. And a lot of the talks leading up to today have set up the ground for that. So I'm not going to spend time advocating for that. Thank you for the wonderful talks ahead of me. So we wanted to build an integrative, interdisciplinary action network grounded in our shared environment of skies and space, the environment that connects us all, because environment is science, but environment is also art, storytelling, language, and our shared identity because we have a shared origin story in the skies. So we have distilled it down today for 4 themes. I will share a bit about the first 2, Ruskin about the next 2. And I'll take just a moment to explain this graphic that I co-developed and then was designed by Alex Meza. The biodiversity and environment one has a number of vertebrates and invertebrates that are affected by light pollution. The Skies for Economic Development has advocacy for responsible lighting in cities, but also away from cities and nature. The Skies for Health has community health, that's the hands coming together. The heart and EKG line are human health, and then ecological health represented by the plants. And of course, we couldn't do justice to the thousands of indigenous sovereign nations, but we picked the Wayfinder canoe. The left sail has the Zuni symbol for the sun, also the state symbol for New Mexico. Inside it is the Canadian First Nations Salish moon. On the right is the dark patches, Mama and Baby Llama for the southern skies. So that's the graphics that we are looking at for this action network. And although at present, ground-based light pollution is by far the leading source, I should say, of light pollution, space-based light pollution is catching up through satellite streaks and soon from quite so many rotating pieces of hardware above us, a building aggregate effect for light pollution. So as we go to the moon and beyond, we need to think about, as the speakers in the previous session already said eloquently, what are we taking with us? Because from my perspective, we're taking not just payloads, but we're exporting legal policy systems and protections. So whatever we didn't get right here, let's learn from that. And also the moon is part of the day-night cycle. We've heard the entire conference from African, indigenous, and other voices, how many ecosystems as well as human beings are sensitive to the humans' cycles of light and dark. And we all look up on the same moon, and it really deserves our protection and thoughtful advocacy as well. So for the next 2 slides, which will be my last 2 slides, I will spend just a minute each on 2 themes. It is inadequate time, so find me today or later down the road to discuss more. In this group, and I want to thank Charles and Brenda. Brenda is the climate manager for the Snoqualmie tribe. Charles, of course, everyone knows, one of the organizers of this GA. We distill down to 5 key action points and advocacy points. Consultation, meaning not just a one-time meeting, but seeking consent, particularly free, informed, and prior consent for communities to be able to freely make decisions that serve their economic and cultural interests. Sovereignty encompasses a huge range of issues: economic sovereignty, cultural sovereignty, and food sovereignty. Because even if you live in a relatively dark place, many tribal communities are not seeing the pollinators arrive anymore. So we are impacted, all of us, by global light pollution, even if we live in a dark place. Language, as I said, is central. Without the environment, much of language and identity goes away. For many indigenous languages at risk, many aspects of indigenous science are highly place-based for their skies, their land, their horizon markers, and so on, and a big part of their storytelling. And of course, as I've already said, we have a shared origin story in the universe, and the way we manage the skies and space affects the rights of future generations. And last, because this is something that we are for, the creativity aspect is one I want to amplify here. It is now documented by research that human beings are more creative in low lighting or dim lighting. And many origin stories, especially indigenous creation chants, are grounded in natural darkness. So I just want to draw attention to that. And I'll conclude with this slide, and we have one of the leads in the audience, Samyukta, who's been a key part of this along with Fernando. Skies for Sustainable Economic Development. And the key goal here is to have a long-term view of what economic wellness and economic development is, not a short-term view of economic gain, and to look at investments in economic health as an investment in human health and environmental health. So I've listed a couple of things here, but there's much more. We are developing documents to go with this. How do we support communities in responsible, sustainable practices around cultural tourism and astrotourism to complement ecotourism? We've heard a lot about that this week, and we'll hear more right after us. And really asking for better lighting strategies rather than just more lighting as a long-term investment for all these regions I've outlined. Again, cheap lighting is good, but it's flooding the environment just like cheap satellites are flooding the space environment. So cheapness is not the only factor. There is a economic and health factor as well. So I'm going to hand it off to Ruskin now, and thank you for your time.
The third area is just skies for health, both our own human health, our public health, our community health. And really here it's about both recognizing again the value that natural darkness plays for our spiritual health, for our mental health and our physical health. Obviously the OED recognizes that. That's one of their polls here. The third area, again, I'm not going to spend much on this, but skies for biodiversity and environment. We heard these incredible stories about the role of both the sun and the moon and the stars for the ability of a dung beetle to navigate their world. And there's just a reminder, half the park, the National Park Service says in the US, half the park is after dark. And I think the broader conservation community, because we're a diurnal species, has generally not thought about what's happening in the nighttime environment. And we need to change that and really elevate the role and the value that natural darkness has and really recognize artificial light at night, light pollution, as something that's stressing that. As we step back, we really came up with three overarching concepts that we wanted to elevate that are pretty simple. So you can see the first is really recognizing natural darkness as a vital component of our environment for all the reasons that we just outlined. Acknowledging artificial light at night as a pollutant. This is not, it's not, if it's useful, it can still be a pollutant. Really elevating artificial light at night and brightening of natural darkness as a pollutant in the same way as you would think about lead in water and pesticides in soil as forms of pollutant, or now carbon dioxide, excessive carbon dioxide in the atmosphere. And critically really adopting, this is not about turning off all the lights and plunging into medieval darkness, but really thinking about using light responsibly, judiciously, whilst protecting natural darkness. So those are the three concepts that really outline that. And this is something we're going to be trying out later this year, right? Can we bring together a broad coalition around the value of natural darkness, a natural darkness action network composed probably of individuals, but I think critically for us to be successful, bringing in other large and small organizations who might not step up and save the night sky for astronomy, but we can connect this to things that they care about and really go and sit down with them, understand what are the values and things that you care about. Can we enter into a dialogue there? Can we speak more broadly when we have more voices participating in this? And again, I think that's the change. This is not about doing this for astronomy. It is about astronomers and conservationists and public health professionals sitting down together in this other space and identifying those common themes and those common threads that we can work on together. And really, when you, again, step back from this one step further, anyone who has been out under a naturally dark sky comes away with that sense of awe. But it changes people. It gives you that different perspective on the world. And really, this is what we advocate for, and I'll let you to read this. So this is a concept that Dark Sky is looking for feedback. At this time, we'll be talking with our board. A number of board members are here. A number of board members were involved in participating it later this month. And really with the goal about, again, creating this collaboration that can move forward together around some of these themes with the belief that it's been pigeonholed primarily as an astronomical interest for the last 35 years, and you can see where that's got us. We need to broaden the tent, we need to we need to build that new space, and we need to then move forward together. So thank you, Connie.
Your presentations are always enlightening. So, okay, so we have next Dr. Hernshaw, and he's going to talk to us about the latest developments at the, I have to learn how to pronounce this correctly, but Araraki Mackenzie International Dark Sky Reserve.
I'm going to tell you a little bit about Aoraki Mackenzie International Dark Sky Reserve. It's the first reserve or dark sky place in New Zealand. And it's just a number of different things which are happening there in recent years. So that actually is a summary of my talk, but I'm going to discuss each of those 7 points in a little bit more detail, so there's no need to read that slide, really. So Aoraki Mackenzie is a reserve in the center of the South Island of New Zealand, and it's I would say, the prominent reserve, prominent dark sky place in our country, and it has 9 astrotourism companies, which is quite a lot. And the largest of those companies is called the Dark Sky Project. And it employs about 100 people. Not all night sky guides, but probably about a third of them are. And they give guided tours in multiple languages. Obviously, English is one, but also Chinese, Japanese, Korean, French, Spanish, maybe German, I'm not sure. So that is doing a great job. Then there are some medium-sized companies. One's called Big Sky Stargazing, another one Tekapo Stargazing, and Silver River Stargazing, Silver River being the Milky Way. And then there are several more which are just with 1 or 2 people running them. So astrotourism is booming in this dark sky reserve, and I think that's a measure of its success. So where is it? New Zealand has 2 main islands, and the South Island is slightly larger, but only a quarter of the population. So the South Island is very underpopulated. About 1 million people live in the South Island. And what is called Mackenzie District is right in this geographical center, just to the east of the mountain range, the Southern Alps, where that arrow is pointing. And our astronomical observatory, belonging to the University of Canterbury, is on the shores of Lake Tekapo, inside the reserve. So the reserve covers 4,367 square kilometers. Observatory. And the actual area of Aoraki Mackenzie International Dark Sky Reserve is the pink area. It includes a national park in the north called Aoraki Mount Cook National Park, but also a large area which encompasses those 2 large lakes, Lake Pukaki on the left, Lake Tekapo on the right. Just to give you an idea of the scale, Tekapo is 25 kilometers long, Pukaki is 30 kilometers long. The whole reserve is about 100 kilometers north-south and about 60 kilometers east-west. So it was created in 2012. There is a proposal at present, which we are going to very shortly apply to Dark Sky International, to extend the area to include not just the pink area there, but the whole of Mackenzie District. A district in our parlance is like a county or in other countries. So Mackenzie District is the area of that map. There's quite a large area to the east, with a small town called Fairley. And the Fairley has a population, oh, I've forgotten, about 1,000 people probably. So the total population of Mackenzie District is around 5,000, and there are 3 small towns within the reserve: Lake Tekapo, population about 600 or 700, Twizel in the south, population of over 1,000, and Mount Cook Village up in the national park, which has just a couple of hundred people, something like that. So the population is very low. And this shows Lake Tekapo, and the village is at the southern end. Mount John Observatory is on that hill to the west or left side, and you can see the Southern Alps in the distance. And the Southern Alps cover the northern part of the skyline as well as to the west. Then there's another range of mountains to the east. So the whole of this Mackenzie Basin is sort of cut off by mountains. So in 2023, the whole of Mackenzie District, including the reserve, had streetlights replaced, and we now have 2,200 Kelvin LED streetlights, phosphor converted amber streetlights. And those new lights, I took a spectrum of one of them, and the blue emission is quite low. I actually measured 2,335 Kelvin, although nominally they're 2,200, but I suppose each individual light shows variations. That's okay, I suppose. Anyway, the amount of blue light, which is the harmful stuff, is moderately low. In the Tekapo village and also in Twizel, most of the roads have these bollards just over 1 meter high and with an LED in the top of that cone. So they give just enough illumination for people to walk around at night. And once again, they're low color temperature LED. I did a plot of the amount of blue emission from different LEDs commercially available, and that shows the relationship between the fraction of blue light defined as lambda less than 530 nanometers and the color temperature. And you can see that if you want to get under 10% blue, under 10% below 530, you really do need to be near 2,000 Kelvin. And if you go to 3,000 or 4,000 Kelvin, the amount of blue becomes alarmingly high. So I don't think you can condone 3,000 Kelvin, which a lot of people are adopting, really, for dark sky places. And well, that's for lambda below 530. The really bad stuff is below 500 nanometers, so perhaps it's a bit under 10% at 2,000. New Zealand is remarkably dark and mainly accessible too, and that shows the 2 islands. I live in Christchurch, which is the main town on the east coast of the South Island, but the center of the South Island, where our reserve is, how much? Only 1? Oh goodness, got to go faster. So the center of the South Island is really dark. And that's just a typical view taken in Tekapo. You can see the coal sack, Southern Cross, pointers, and so on. Astrotourism has made a big difference. Guest nights, people staying in Tekapo have increased substantially over 5 years, as you can see, being roughly doubled. That's guest nights, and they're spending a lot of money in our reserve. After creating our Iraqi Mackenzie Reserve in 2012, the expenditure, these are New Zealand dollars, divided by 0.6 to get US dollars, have gone up from $120 million per year to about, by 2018, 300. By 2019, when the pandemic started, it was about $1 million a day. So the reserve astrotourism made a huge difference. We are having a conference in New Zealand in October, and it's run by the Aoraki Mackenzie International Dark Sky Reserve, together with our Royal Astronomical Society of New Zealand. And the dates are there. Please come if you wish. It's a very multidisciplinary conference, not just astronomy, but also human health, environmental impact, astrophotography, everything, lighting technology. So here are all the existing 7 of them, and aspiring about 24 places in New Zealand. So there's a very strong New Zealand dark sky network. Have I run out of time? I was just going to say 20 seconds, that's enough. I submitted a petition last year to our government, to the House of Representatives, saying we need a national legislation to cover light pollution in our country. It's just too much trying to explain to every one of about 60 local government entities that they need a lighting ordinance, and giving the same story over and over again to people who've got no concept of anything scientific is hard work. Having a national legislation would overcome all that. And let's not worry about that. There's a nice picture taken in Mount Cook National Park. Thank you.
Oh.
We can ask as many as you like, as far as I'm concerned.
Thank you, John. Mackenzie in astrotourism terms is, you know, adulting goals for those of us who are junior in this industry. The question I have, you gave figures about the growth in astrotourism and the economic value it's generating for Mackenzie. How do you know that is from astrotourism? Because my understanding is that Mackenzie has an extensive other range of tourism.
Mackenzie District gets about 1.5 million tourists per year. We think about 10% of 1.5 million are astrotourists. That's not just a guess, because the companies can tell us how many people they have on a tour. And Dark Sky Project has about 3 or 4 tours lasting 2 hours every clear night, and there's sort of 40, 50 people on each tour. So the numbers are in principle known.
I think we're going to have to hold questions, I think, because we need to keep to the schedule a little bit. We're a little bit over right now. Okay, so we do have, and John, will you be around to answer questions afterwards? John, will you be around to answer questions at the end? Okay, please, because there seem to be a few that need to be asked. Okay, so we have next, we have Tesney Pugh, who's going to be talking about dark sky successes in Southwest Texas, and she is online. So do we have Tesney? Tesney?
I'm here, Connie. I just had to turn my audio on. I apologize.
That's okay. Go ahead.
Can you see my slides?
We can, and we can see you too.
Perfect. We'll get going. So I just want to give a really quick thanks to Connie and James for allowing me to give this talk, and apologize for not being there in person. And I want to give gracious thanks to Stephen Hummel, my collaborator, who does most of the work for McDonald Observatory and the Greater Big Bend International Dark Sky Reserve here in Southwest Texas. So just to geographically locate us, we are right in the corner of southern Texas, bordering New Mexico to the north and Mexico to the south, about 500 miles or almost 600 kilometers from our parent campus at the University of Texas, Austin. We, and I will go into this shortly, were designated, the area around us was designated as a dark sky reserve in 2022. And today I'm going to talk about some of the further successes we've had since that designation, which has resulted in us having almost 30,000 square kilometers of Southwest Texas now under lighting ordinances that match the lighting management plan of the reserve. Much like the last talk, we are sparsely populated, so there's only about 50,000 people in that whole 30,000 square kilometers. But to put that in a geographic sense, because I have no idea how big that really is until I look at it compared to other places, it's more than the total land area of Hawaii, more than the countries of Armenia and Burundi, and larger than Lake Winnipeg, for those of you in North America that understand how large our lakes are. So just for a really quick piece of background, McDonald Observatory's dark sky advocacy story begins in 1976. So the state of Texas allows no power to the counties other than administrative powers. They have no policy or jurisdictional power. But in 1976, the state of Texas decreed that the 7 counties around McDonald Observatory, so here, would be allowed to have lighting ordinances to protect the night skies above the observatory. And in 2012, they furthered that language by saying that these counties must have lighting ordinances. And before 2012, only 6 of the 7 had instituted lighting ordinances, with the outlier being Reeves County. And I will talk a little bit about why they were the outlier in that going forward. But since 2012, all of these counties and the municipalities within them that are shown in red have had lighting ordinances. And between 2020 and 2022, those lighting ordinances were updated to bring them in line with the lighting management plan per IDA's Big 5 recommendations. So in 2022, in collaboration with Big Bend National Park, several Texas state parks, and the Nature Conservancy, plus obviously municipalities and counties, we were certified as the Greater Big Bend National Dark Sky Reserve. This is a 24,000 square acre dark sky reserve that encompasses this portion of Southwest Texas and northern parts of 2 states in Mexico. So we also had to work with the land protection agencies in Mexico to bring this in place. And we govern via a committee of representatives from all across the area, because it's such a large area to govern that we have to do it in a shared manner. And we have to work really closely together. So that was where we stood as of 2022. Many of the ordinances have written into them that by the end of 2025, everywhere will be all businesses will be in compliance. Most of the residential lighting is already in compliance at this point, and the aim is that by the end of 2026, everything within the reserve will be in compliance with our lighting management plan, and we're about 80% of the way there at this point. What I'm going to talk about is outside of our area. So this is a natural source subtracted all-sky photometry image taken from the observatory last April. And you can see we have a rather large light pollution issue on our northeastern border. And this is caused by the oil and gas industry in Texas. So they are the largest threat to the dark sky reserve for us in the northern portion of the dark sky reserve. And in the south, there is a large population center just south of the border that the national park and state parks are working with to bear their lighting. But we're focusing from McDonald on this issue to the north of us. So Stephen Hummel, who I mentioned at the beginning, put in a request to the ISS to get night sky imagery taken, nighttime imagery taken over us so we could see the issue. So to the northeast of the observatory, this map isn't oriented north. You can see it looks straight north to us, but they're actually northeast of us. You see the most lit area per person in the United States, and this is the Delaware Oil Basin. It's a directional drilling oil field, one of the largest oil field reserves in North America. And in 2015, there was a real oil boom in that area, and that has been the largest impact for McDonald Observatory's dark skies since that time. So most of our work focuses on building relations with the oil and gas industry and getting lighting practices improved across the industry. In 2018, we worked with Apache Corporation, who are one of the largest rig operators in the Delaware Basin, to put into place recommended lighting practices for oil and gas across Texas. And these were recognized by the Texas Oil and Gas Association and the Permian Basin Petroleum Association and the Texas Railroad Commission, who are the people that regulate oil and gas production in Texas. These are just recommended practices, but they do go out through the Railroad Commission to the Texas oil and gas industry. And as over the last year, this has expanded to New Mexico oil and gas. And Stephen is now working with Dark Sky International, thank you, Ruskin, and New Mexico oil and gas and several of the largest operators of oil and gas across that region to generate new industry practices and to generate a lighting recognition program for the industry that they can use going forward. So that's a work in progress. Thanks, Connie. And we expect that to be completed hopefully by November this year. It may take a little longer than that to do. We've also been working with TxDOT, so our Department of Transportation, and we have got agreement from them that for the Odessa region, which doesn't include us, we're actually part of the El Paso region, but for the oil and gas industry area, to institute 2700 Kelvin lighting for high traffic regions and 2200 Kelvin lighting for smaller areas. This picture is a sample intersection that's near one of our state parks. It currently has 4000 Kelvin lighting, and in the next fiscal year that will be swapped out, and that's going to be their test station where they will actually be measuring if there is an increase in road traffic incidents at that intersection. So data to follow in the coming year. We're also working with our local communities, so talking about the multifaceted nature of dealing with light pollution. These are lights outside of a Family Dollar. For those outside the US, Family Dollar is a cheaper store that runs in rural neighborhoods. They have about 15,000 stores nationwide. They've agreed to change out their lighting in our region, but are also aiming to incorporate the lighting practices they develop for our region to all of the Family Dollars in dark sky areas across the United States. And our aim is that long term, we can push them to do that as a general practice throughout the region. Just to go, this is one of our elementary schools where we provided lighting for them to do an update. We do that on a regular basis for the companies and places that can't afford to do it for themselves. And then finally, I'll talk a tiny second about tourism. This is actually my last slide. What I want to say is we have a big support from the local community for all of the lighting practices. And last year, the Brewster County Tourism Agency funded a study that showed 2/3 of all of the visitors to our region participate in nighttime activities. So astrotourism is a really big financial generator for our region. Thank you.
Tessie, this is Ruskin. Thank you for the presentation. As you know, one of my colleagues, Amber, lives in that region, who runs our Dark Sky Places program. One of her observations recently has been that the success and the recognition of the Dark Sky Reserve has brought new people into the region, in part because we can now work remotely, and with them, they may be bringing their practices, lighting practices from outside the region. Do you have any wisdom or insight in terms of how dark sky reserves can sort of protect and defend against that, so that when the people come, you don't destroy what you're trying to protect?
Yeah, and Amber's got a really good insight to that because of where she lives. The south part of our reserve suffers much more than the northern portions of our reserve with that. We have actually just had some success like yesterday. So, but I think it's education, right? It's getting to the community members that are already there know it, but you have to be consistent in getting into the community on a regular basis and talking to them. So we've expanded from McDonald our dark sky programming to incorporate the southern region so that we can help the National Park Service and Texas Parks and Wildlife expand their programming a little bit north to kind of capture that region where this is really a problem. But what we find is when we go out there and talk to them, especially the people that are developing businesses out there, they're really responsive and they do make changes. It just takes time and money to get those through. The other part is our recognition program. We have a lot of the people that are coming out and starting like Airbnbs and things in the region that are really responsive to that because they want to post it all over their advertisements. So like you were saying with yours and Aparna's talks, it's figuring out what makes people tick to get the right conversation going, right? So it's for them, it's very much the business aspect and the ecological impact side of it, right? A lot of them love astronomy, but they don't care enough about it. They worry about lighting for astronomy purposes, but what they care about is the rural lifestyle and their own economic interests.
Tesney, James Lowenthal here. Hi, thank you. Can you just say a couple of words about how you, what were some of the keys to getting the oil and gas industry to change their ways? You know, how did you convince them? And same question for Texas DOT. In the States, most highway departments are convinced that 4,000K is required for safety and 2,200K is going to lead to mass pileups on all interstates and lock up the entire country and crashes. How did you convince Texas Department of Transportation to change?
Yeah, so oil and gas was easy because it's a win-win for them because they save money, because we're saying also lessen the number of light fixtures. They like that. With the necessity to make environmental statements now, the impact of lighting on populations of migratory species and things like that in our regions are really helpful avenue. So we just have to be really broad in our conversations. TxDOT was more difficult because that was their automatic reaction was 4,000 Kelvin. It's been shown, the studies show that. That is why they've gone, we will start with this one intersection and we will measure what happens for a 6-month period. And if there's no increase in accident rates, they've promised to spread it out beyond that. So I will follow up with data once they get through. Having the ordinances helped because they were like, well, we should comply. They don't have to, but they felt ethically obligated to, even though they didn't have to, which is why they initially agreed to do the test run.
Well, thank you. We have one question that I think is applicable for both John to answer and Tesney to answer. Thank you, Aparna, for bringing it to my attention. And it states that how has the public reacted to the change of color of the outdoor lighting? And both of you can answer if you'd like.
If I can go really quick, the public here love it. And when anyone puts in a blue light now, we get a phone call reporting them. So the public in our area really like it. But we are a naturally very, very dark region. So it's really noticeable when something's different and causing a problem.
Is it on? I would say in New Zealand, everyone loves low color temperature street lighting. And the 4,000 Kelvin, for example, is so harsh and unpleasant to look at. People hate it, especially if there's light trespass into bedrooms. But if the warm amber color of low color temperature lights is what people actually like. And I do believe that the roads are just as safe as they ever were.
Excellent. Thank you. That's good news. Okay, we're going to go on to the next talk, if that's all right. We have a talk by Nalini Davies, and it's on the synergy between astrotourism, dark sky conservation, and astronomical outreach. Nalini? If you need this, we'll leave it there.
Good afternoon, everyone. I'm giving this talk on behalf of Dark Sky International. A group of us have been working inside in an astrotourism working group Although I have listed myself and Ruskin as the authors, there are 3 others in the team. The only reason I couldn't list them was I put this abstract in at the last minute, and it required me to get permission from each of the authors. It was Connie Walker, Samyukta Manikumar, and Mike Simmons. So the key thing that we noticed inside Dark Sky International is how astrotourism was trending. Not only was it trending, it was growing at an accelerated rate like the universe. I picked up this magazine yesterday in the exhibition hall. It's a brick astronomy magazine, astrotourism in South Africa, astrotourism in Russia, astrotourism in India, astrotourism in China, and astrotourism in Brazil. This is all the BRIC countries. And under each article, there were at least 5 or 6 places listed. And Dark Sky International hasn't certified a great many of them. So Condé Nast Traveler, #1 travel trend for 2024. These are some examples. Lonely Planet, Stargazing Around the World Guide, February 24. New York Times, 4 of the 52 places to go in 22. 24 was IDSP's. Top travel trend by Lonely Planet, Airbnb, National Geographic. And so wherever you look, astrotourism is really trending. And that's what got us into thinking, should Dark Sky International have a view on astrotourism, which is a commercial activity? So we started by conducting a survey because we wanted to first find out what's really going on in our dark sky places. So those are the names of the people: Mike Simmons, Connie Walker, Samyukta, Ruskin, and myself. Mira Bradshaw is, she's a director of Nielsen's market research in New Zealand. So our survey was professionally analyzed for us. We were lucky, she happens to be my daughter, so she couldn't say no. So that's really the response profile. We had 52% response rate, which is good for a survey. But what we really conducted, which we didn't realize until she told me, was actually an invited census by invitation, because we requested every single one of our dark sky places, 209 of them. So this is supposed to be a very high rate because it was by invitation and not legally required. And the profile shows the responses were representative of our dark sky places geographically. So this is considered a robust, rich data set. So the findings are good. More than 60% of the certified dark sky places have been certified by Dark Sky International. 25% by Starlight Foundation, and they promote astrotourism. So we are very confident of our findings. So what we found out overall, I'm only sharing the extract that's relevant, is dark sky places are supporting astrotourism. How are they doing that? This was one of the questions. What's the potential for astrotourism part of your reason for requesting certification? 83% said it was important or very important, 100% of the reserves and 85% of the parks. So this was a very important factor in their request for certification, which we became aware of late last year. The next question was, did you start astrotourism before or after your dark sky place was certified? One of the reasons this question was put in is, I know Ulrike Mackenzie that John talked about, astrotourism was in place from 2005, and it was the astrotourists who drove the desire to have it certified in 2012. And the answer was 64% before they were certified, 75% of the reserves, 64% of the parks. And the last question was, how long have you made commercial activities been available? 75% have been doing it for less than 10 years, which is good because astrotourism is still in its early stages. So this shows that dark sky places are supporting astrotourism in a significant way. The next question we asked was astrotourism, we found out was astrotourism actually helps to promote dark sky conservation. So one of the questions was, are responsible lighting practices being followed? 94% said yes. we were disappointed that it wasn't 100%. Our efforts in place to ensure activities are environmentally friendly, again, 93%. And our indigenous astronomical practices integrated into astrotourism activities. In Asia, 75% said yes, Australasia, 57, Europe, 45, North America, 38%. So it is being integrated to varying degrees depending on where you are geographically. And we also asked for some feedback on exactly the magnitude of this. So dark sky conservation is increasing astrotourism. Annual growth in astrotourism since certification is at least 10%, which is per annum, according to 80% of the respondents, and 16% per annum, according to 50% of the respondents. So this is pretty high levels. What percentage of commercial astrotourism participants are international, had international visitors? 59% said 25%, 11% said over 50%. So from all of this, we realized that we need to do something about astrotourism because it's being practiced on the ground at our dark sky places in a much more significant way than we had realized. Astronomy is still the most dominant nighttime activity. We do talk about nighttime tourism and dark sky tourism. So we specifically asked the question, astronomy versus non-astronomy activities undertaken in parks. 73% of all activities were astronomy related. In the reserves, it was 72%, parks 77%, sanctuaries 87%, communities, which are not all that dark, was down to 55%. Now, this is counting astronomy in a very conservative way. I better go very quickly now. Outreach is basically astrotourism, which is not paid. 51% of the activities were unpaid activities, and quite a lot of it in all these places. So there were objections to astrotourism activities. We did ask the question, and in various places, the percentages were different. About 13% of the places reported there were objections. The frequent objections related to adverse impact on natural environment, nocturnal life, ecosystem, impact on resident population from too many visitors, overdevelopment of the DSP, or other changes in the area's character. So the essence of it was dark sky conservation leads to astrotourism and astronomical outreach, and vice versa. Conservation benefits astronomy. There's the enjoyment, education, conservation of cultural history and practices. But these activities need to be undertaken sustainably. So the same team developed, it's the same team, we developed what we call responsible principles. These principles are just not rules, just guidelines to be adapted depending on the unique circumstances of the places. And we are inviting operators to adopt these principles. We'll be rolling them out soon. These are the 6 principles. First one is to use light responsibly, to basically adopt the Roland principles. Second one is to consider the environment. Whatever nighttime activities you do, don't harm wildlife or the natural environment. Third one is to consider the local society. There are residents, as we discussed at the workshop yesterday. Most people live in that area. They're not working in the area on astrotourism. So one needs to take on board their well-being. Indigenous culture. When you do this, integrate it, do it respectfully, collaboratively, and very sensitively. And follow relevant local regulations. You'll be surprised how often people don't even know what the local regulations are. And finally, generate economic benefits for the local people and communities. So to recap, these are the 6 principles. The reason we brought this here, this is the first time that these principles are being aired outside of our little working group. The reason was we want to finalize the principles after integrating useful feedback. If anyone has feedback, we know the astronomical community will stand behind these, but any useful feedback will be valued. We also want to invite collaborations to widen the application of the principles. We expect the IAU officers to be supportive of this, but we want to take it beyond that, especially to tourism organizations, umbrella organizations, collaborators, as I've said, influential international travel organizations. And then we want to develop an implementation program to roll it out, starting with our 200 dark sky places, then the aspiring dark sky places, another 200 other certified places, and write to all these people who want to do astrotourism, and hopefully get some sort of weight on it, a bit like our responsible principles of lighting. So what we want is any feedback that you have.
So I think we have time for, unfortunately, one question. Yes. Oh.
I also have some printouts if anyone is interested.
Thank you so much. That was a really good presentation. I loved it. I just want to say that I think it's a really good initiative. That's exactly what we need to do. I come from the social sciences, so I love surveys. That's what we do. That's what we do. Are you thinking about Are you thinking about replicating this with, for example, governments, to see if governments are, if they are considering, astrotourism as an economic activity, which in some of the groups that I'm working with, we know that we have an idea that maybe they are considering because of economic, they're driven because of the economic aspects. But are you thinking about maybe replicating this for governments, if governments local or national or central governments? Because that could be a really interesting work to do. That would be really good. So that's it. I loved it. Thank you.
Yeah, to answer the question, I'm doing a lot of work with the New Zealand Tourism Agency. The Minister for Tourism is attending the Starlight Conference, so we could get it out through them. But the idea is to roll it out through every available medium.
So not to forget the people online, and thank you again. No. So it's from Eduardo Unda Sanzana, excuse me. And then have visitors been surveyed about their motivations to visit the dark sky places to assess whether the certifications are a part of their motivation to visit those sites?
I understand the question. We haven't surveyed the visitors, right? But I know from my experience in New Zealand that visitors, some of them are destination places, like Auraki Mackenzie. There are plane loads that come from China. They just fly straight into Christchurch, that's why they give tours in Chinese. And Great Barrier Island is the same. It can be a destination place. But in other places, it's just an overlay. They're there. There are no nightclubs in these rural areas. It's a dark sky reserve, and they do it. So but we haven't surveyed the visitors. John, have Auraki Mackenzie surveyed the visitors? Yeah.
Well, unfortunately, we don't have time for other questions, but I hope you guys will stick around a little bit at the end. We might have some time for general questions. And next we have Yes, I want to celebrate all of the people who have been speaking, and I appreciate your applause on that, and forgive me for not recommending it. Okay, so we have somebody coming up now to talk about raising dark sky tourism and light pollution awareness, the amazing dark sky in Thailand. And forgive me if I don't say your name.
Don't worry about it. Okay. Hello, everyone. Matipon, or just Matipon is fine. So I'm
So I'm from the National Astronomical Research Institute of Thailand. We're actually a research institute in astronomy. And so this needs a bit of a background explanation. So 15 years ago, when we started this research organization, there was nothing at all with outreach astronomy going on in Thailand. Most people don't really know what astronomy means. And so when we found this institution, we realized right away, we need to do something about it. So we undertook a very ambitious project, and it eventually panned out. And if you attend the very first day of GA, we received an award this year for our outreach work. And what this means is we recognize that there was a lot of missing outreach infrastructure in Thailand. And in order to get the momentum going, get the astronomy to be on the page of everybody's mind, we need to completely redo everything, and in a really novel way. So we, as a research institution, we decide we have to take all the responsibility to ourselves. And this starts with building regional observatories for the public. We are the operators of not one, but currently 5 regional observatories for the public, planetariums. We do a lot of teacher training workshops. We do science camp. We do stargazing party. We do everything you can think of in astronomy outreach. We probably have done it in one way or another. And you can see that the number of participants has been soaring over the years. Last year, we've interacted with about 674,000 people, and we're pretty sure this year, it probably either this year, next, we're going to reach 1 million people that we outreach every single year. And keep in mind, this number comes from essentially zero. So now it's astronomy is at all-time high, and and now there's more interest than ever in astronomy. But more importantly, we're in a unique position where not only now astronomy is new, everybody's on everybody's mind, but astronomy is synonymous with the name of our institution, NARIT. So everybody knows, astronomy, probably first learned it through us, but now there are also many other players here, but we're still pretty familiar with the people. So this puts out, the reason I'm telling you this, because this puts us in a really great position to promote dark sky tourism, because now more than ever, people learn enough about astronomy, they want to see the real thing. And they're looking for advice for some people they recognize like us. So this is why we undertook this Thailand Dark Sky Tourism Program. So we want to establish Dark Sky Preserve for Thailand. Now, there are many benefits, which, I'm sure you're all aware of, that we're all in here. We're probably familiar. I'm not going to bother with the details. But so we have an application process that people can submit to us, and we can go and evaluate a process, field survey, evaluate them, and then we register them. And because we're such a well-known institution in astronomy by now, we are the authority as far as the public concerned in astronomy in Thailand. This stamp of approval from our institution means a lot to the public and to the people who actually gain interest in astronomy, probably via us to begin with. So we have a couple selection criteria. So, I'll go with each one of them at a time. So first off, obviously, to be a dark sky, you need to have sky darkness. Unfortunately, Thailand is a very urban country. So if we really go into like the regular Borel scales, it's not gonna be as good. So we're not gonna be internationally quality sky tourism. So, but we still, there are some darker places. It's just not going to be at an international standard. So we look for other ways to incentivize, to evaluate them. And, with this, we would like to have a sky where you can see all these beautiful things, but no, that's not always you're going to get. So we also have other criteria that we look, like do they have observation site? Can you see the horizon? Do you have full view of sky? And we go out, we send a team, we will observe the site, will take pictures just like this one, and we evaluate how much of a sky at the site you can, percentage we can see. And then, of course, there's also going to be how light pollution management, how well they do. And at this point, we're nowhere. So I've heard these talk about, changing the light, changing that. I'm really, really really wish we could do that, but we're not right there yet. But it's just, this is because we need first to get the public opinion, public interest to be with this. So right now we're just going for whether the owner of the venue or the place or the community have proper light management, and maybe someday we'll get a chance to get at it at the legislation level, hopefully. So you just like good use of light fixture, bad use of light fixture, and so on. Turn off, whether to turn it off when they're not used, proper use of lighting, using the right color. But also, because whole thing is about promoting astrotourism, we want to evaluate some other things besides just the light pollution. So do they have amenities to service the tourists? Do they have personnel and equipment? Do they have someone who can explain to the tourists what is going on? Do they have equipment? Do they have telescopes to service the tourist industry? And is this accessible? Do people have to drive? If people can't drive to the site, do they have like a shuttle service? So these are all the things that we evaluate each of the dark sky site. And the dark sky site comes in different varieties. So you either have dark sky parks, these are national parks area that is also can request to be evaluated, and we evaluate them. There are some dark sky communities. So if it's a community, a village or something, with all these criteria, then you can award them. Or if it's a dark sky private property, this is usually resorts or hotels, somewhere that they would like to have additional income from astrotourism. And of course, there's also dark sky suburbs, if it's in a suburban area that have enough awareness. So these are the 4 categories that we look for. And for the first year we done this, we only started this program 3 years ago, 2 or 3 years ago. And the first year we did this, we have 12 registered dark sky sites in Thailand, and they are scattered all over Thailand. And then the next year we evaluate some more at dark sky site, and becomes 30 sites. There's a lot going on. So I'm sorry. So I'm taking pictures, trying to take pictures, and I keep switching slides. So maybe I should hold on a little bit. And this is currently we also have a website that you can look at. They can browse all the sites that we have evaluated and awarded. And then so some of the things that people who have been awarded this registered sky site, one of the things they have to do is that they have to report the stargazing events. If they have done an event, how many people they come, so we can put it in together. We can collect some data about what kind of people come and how often, and how each of the sites are doing. And if they keep doing this at God All Awards, one of the benefit is, they get the badge, and they can put this right in front of there. And, and this is really especially particular meaningful to them because, as I mentioned in the beginning, everybody in Thailand who is interested in astronomy recognize who Narit is. So getting a badge that this is a dark sky site by Narit, it has a lot of meaning to them. And also our social media has about 700,000 followers. So when they are recognized as a dark sky site, it gets a lot of attention from the public as well. And we also try to promote, because it's also not just about the site, but about the people and about the equipment. So we also have some online talk and discussion. We also have Astro Guide training. They can send staff to train with us. And we have a little exam, just a quick short knowledge about astronomy. And if they pass, they can get a little certificate that are the Astro Guide certified by Narit. Right, and for obviously for some of them that has an increased economic value to them. And we have also done some training for astronomical training for park rangers, because a lot of our dark sky sites are the national parks. So there's a lot of park rangers. These are not necessarily related to the paid services, but the added knowledge to them, they can do more explaining to people what's going on. And to promote some of the awareness, we also have many different varieties of activities. So first is Astrophoto Marathon. This is to appease, obviously, one of the biggest benefit, people who benefit from the dark sky sites are the astrophotographers. So we do astrophotography marathon, teaching people how to take pictures of the stars. And we would do this, rotate each year to different dark sky sites, and people learning. The more they learn, the more they want to take pictures, and the more they want to seek new places to go. And we also have, sometime we have an exhibition promoting the astrotourism with our dark sky, Amazing Dark Sky in Thailand programs. And we also have special events that promote dark sky. For example, the Geminids meteor shower. Just last year, we had about 1,800 participants coming. And this is the next year we had 2,500, and this is becoming more and more, these thousands of people becoming more and more usual sceneries that we've seen over the years. But most importantly at all, this is so we decided we want to promote. It sounds a little weird. We want to promote dark sky tourism in the capital city of Bangkok. All right, we've never done event in Bangkok before for obvious reasons, but you know, a lot of our fan base is there, a lot of people interested there. We just want to be inspired. So we did this in the December 23rd last year, and for 4 hours, we have about 12,695 people. And to my knowledge, this is the largest collection of people gathering for stargazing events ever recorded by mankind. The current Guinness World Record is only 2,400, by the way. And we also have activity. These are some of the past activities that each of the dark sky sites do themselves. So I mean, it's not just us who do this. You can see these people also do other things as well. And just to you can definitely see from these that the interest is increasing. There's a lot of activities, a lot of participants in different activities. The events held by Dark Sky Site Network is already pretty big, but you know, the total visitors to each of the total dark sky site is increasing. And before this, obviously we didn't have any. And so that would be pretty much it. If you want to know what 12,000 people look like in a single venue, this is a picture of one of our, obviously this is not a dark sky site at all. We cannot do that with this many people. If you're interested to hear more about us and you'd like to visit us, I just like to have a short commercial break that we have a conference this November. If you want to know more, you can come take one of these flyers. Thank you.
Yeah, good. Okay, I think we have time for just one question, if that's okay. Okay. Oh yeah, James, do you have, I don't know where the other one is, but yeah.
My question actually is like, where do you get all the funding to do all of this? It's incredible work. Yeah, thanks for your talk.
Great question.
Talking this mic, yeah, I think that works. So all the funding is from a public, we're a public organization. All the funding, 100% of it is from the government funding. We are a research institution, but we dedicate we put a lot of dedication to the outreach work. We have one of the largest outreach teams. We have 60 full-time outreach staff. And we set aside about 5% of our budget goes into outreach, which is probably one of the biggest in terms of research institution. But when you do it to this scale, if you calculate it, each participants only need about $1 to fund our entire outreach program, including all these dark sky sites. This is just a tiny part of our outreach projects. What's that? It's all from the government. And interestingly, when like in the early years, our research facility hasn't really been established yet. It was this outreach success that was allow us to convince the policymaker that we're doing something good. And we with overwhelming public support, it is much easier to get more funding for not just for outreach, but for research. So this is one of the rare cases where actually the outreach is carrying the research budget in a way. Yes.
It's really amazing. When I saw your slide with all those facilities on there, I have to admit, I got really jealous. That was pretty impressive. Well, let's thank our speaker once again. Yeah, we have one more presentation, and this one is on basically online. It is a recording, and it is by Exodus. Dr. Exodus, and it's astronomy education for sustainable practices and community engagement. And if we can start rolling, that would be really great.
Hello everyone, I'm Exodus Chen Seats from Hong Kong, China, and today my sharing will be related to the dark sky education and also the initiative on how we can apply dark sky into astronomy education. We are faced with a lot of different urban light pollutions from the artificial light at nights. And also we wish to promote public science and dark sky awareness. So a few years ago, I found a project called STEM per se and astronomy, which is interdisciplinary projects that allowing astronomers and cross disciplines collaborations in order to promote popular science and also try out some new approaches about astronomy education. So A belongs to the analysis. So it's really important that we can redefine what is astronomy. Traditionally, astronomy will be related to some astrophysics, mathematical calculation, but after the COVID, we are always exploring new different angles to consider in astronomy, not just science, but also in some cultural or social perspective. So another will be related to the paradigm shift. That's it's really important that we have to think of the cause and effects relationship of astronomy to our target audience with different needs. Besides that, we can also think of the design thinking model. That is really important that it's really important that the empathy is always required if we try to teach someone or to share the knowledge about astronomy with some people without scientific background or some limitation of resources. And S stands for the sustainability. So sustainable development goals are really important. That's to provide some quality education, or it will always be one of the guidelines or a really good samples that we can always think or redefining our purpose of science communications. Why are we trying to promote astronomy to some people? Why do we start a lot of new things about some dark sky approaches? So it really needs to define some outcomes for every actions or every activities that we are trying to organize. So artificial light and nights in Hong Kong, so it's really strong. That's affecting with some astronomy education projects or some carnival. And besides some skyline show in Hong Kong, and which might affect the cyber astronomy activities. And sky grow that we're always facing with in Hong Kong, the diffuse light source in some districts, and also affecting the night animals in some rural areas. So in Hong Kong, with reference to the Hong Kong Night Sky Brightness Monitoring Network, and the light pollution in Hong Kong is really serious in Central City, for example, in Tsim Sha Tsui or in the Hong Kong Island, which is 1,200 times than the darkest sky. For example, with some dark sky activities that we have tried out to allow more people to see the night sky, to learn about the stargazing manner. Besides, we also have an astro park in Hong Kong. It's really great to let more younger generation to know more about the ancient Chinese astronomical instruments. There are also some observatory by some local astronomical organizations that were able to have some outreach activities and about observational astronomy and astrophotography. And night sky field trips would be a new trend for to let the public to know more about the night sky and light pollutions, because allow people to really see and compare the stars that they can see in the rural areas and in the central city, that they are only see some few iconic constellations or planets or moon, and no other stars or other things that they are able to see to learn about the constellations. So I think it could be one of the future trends. And besides, also allowing the general public to really measure the night sky brightness and contributing in some science, citizen science projects, they can contribute and promote the popular science. And start walking in some regions that allowing people to compare the outdoor lighting approaches in different places to really know the needs of different places. And this is the night sky in my places with some meteor shower and not many stars that we are able to see. But luckily that we are able to see the meteor shower in some places are really far from that are really far from the central city. And there are a lot of different technologies, applications that we can try out the software that could motivate the learning of dark sky. For example, the night sky measurement, and also some light sky brightness, light pollution map, and also some light sky brightness detector for learning about astronomy in different ways. And also some citizen science project that we can contribute in order to motivate the astronomy research for more people in other places without borders. And responsibility. So actually, astronomy is really important that the night sky is our precious and universal heritage, that we have the right to protect them, to save the night sky in order to let more younger generation to have chances to learn about the constellations, the astronomical objects in the night sky, and also the Milky Way galaxy. And there are a lot of light animals affected by the light pollutions that we can in the science communication, we can try out some photography in order to let more people to know more about the animals living in night sky might be affected by the light pollution. And the penguin in Australia, Tasmania, and there are a lot of nighttime animals that under the light pollutions may affecting their living habitats. And some other pictures. And there are a lot of different approaches. For example, setting up international dark sky parks, so in order to have some initiative collaborating with different stakeholders in that places in order to have some light polluted approaches, and in order to reduce light pollutions with some dark sky approaches. And there are a lot of different international dark sky community. And also besides that, some personal behavior guidelines that we can try out in order to be responsible to the outdoor lighting, to promote the stargazing manner in order to let more people to know more about the importance of the night sky approaches, and saving our night sky by some personal belongings and behaviors. Bottle scale could be a really good tools to let more people to know more about the measurement of brightness of night sky by by observing with the number of constellations that they can able to see, comparing in different places. And there are a lot of different festivals and activities that we can try out or engage to participate in order to have some collaboration. And finally, which is about the open-mindedness. So it's really important that it's always to be open-minded and creative, to think of new ideas and possibilities year by year, because by starting up some prototype of dark sky initiative could visualize the process that with some good practice that we can try out in our home, that might be helpful to make the dark sky education more visualized and interesting, and allowing more people to really engage in learning some new things about environmental issues and astronomy. For example, the light up constellations, and also some dark sky friendly light shields that we can try it out at home and in the classrooms. So in our future plan that we wish to develop, which is related to the science communication, interdisciplinary education, and ideas, which is with 5 elements that we wish to achieve in the future. And this is my sharing, and thank you everyone. And if you have any questions, please feel free to email me for more information, or we are looking forward for new possibilities and new collaboration in the future. Thank you everyone.
Yeah, I wish Exodus was here, but he's not. He's not online. So what I'd like to do now is, if you don't mind, we only have a few minutes. We'd like to call up the other 2 co-chairs and kind of wrap up our thoughts and see if you have any of your own. But if you remember, most of us, I think, if I'm looking around at our faces, we're here for most of the day. And what we started off by doing is we actually heard from a number of different organizations, like we heard about Compass at the AAS. We heard about efforts being done at some of the at Dark Sky Preserve and at a National Observatory at NOIRLab in the US. And we heard about measurements of a night sky brightness at these various places as well. And then we went into our second session. Oh, we had a beautiful lunch session, actually, where we had a very great talk by Marcus Burns on light pollution relative to the dung beetle, and then went into the afternoon with radio astronomy. A lot of at least three talks on radio astronomy. I think actually we had up to 6 talks that session. But and then we learned a little bit more about in the third session here about our dark sky reserves and other related things about our cultural astronomy, and we really had some very good all-encompassing kind of approaches to trying to preserve our night sky. And with that, I don't know if you guys want to say more, and then we can ask our audience what their impression was of all these things.
Since we're at the end of the time, I'm not sure how much discussion we're going to be able to have, but I want to invite people to think now as we launch into the next triennium of IAU, what this organization can and should do. Please put on your thinking caps and get back to us organizers who are on this, on the executive committee working group and the Commission B7. What should the IAU be doing specifically to address all the critical issues that have been raised today? And I just want to thank everybody so much for your time and attention, and pass it to Ramatola.
Yeah, I don't have much to say, but I would like to thank everyone as well for being involved in this talks, and yeah, we really appreciate. And following on what James has just said, yeah, we have been talking about how the community of IAU can be involved in this, and we really would appreciate any feedback from you or suggestions on how we can just take this forward and not wait for another 3 years.
We had a meeting just a few days ago of the B7 Commission, which is the one on site protection. So you please email any one of us, because we're going to start off with a meeting in the next month to try to further develop ideas for what we should be doing in the next triennium. So if you want to get involved, just please feel free to contact any one of us. And we have a question from Ruskin.
So I have a challenge. So I was really inspired by the description of what's been happening in Thailand and how a public investment in outreach and education can build support for research and facilities. And so the challenge would be, would the IAU ever consider adopting a resolution encouraging every national research funding institution to match Thailand and invest 5% of their budgets in outreach, education, engagement to support protection, but also to support in their enlightened self-interest to build a community who understands and continues to support those investments in basic science and research. That would be a bold statement from IAU.
There's an actionable suggestion. Thank you so much, Ruskin. And we want to hear similar from everybody else as well. Oh, yes, we have a response.
So I know that the IAU is encouraging research institutions to put 1% of their budget into outreach, and I know that most of them don't meet this criteria. And I mean, 5% sounds like a big number, but you also should keep in mind that 5% of our budget, it's much smaller than 1% of your budget, to be honest.
So it hurts even more, to be honest.
Yes.
Arne.
Sorry. I just wanted to say it's amazing to see all these dark sky leadership here together. And I think if there could just, be a conference to bring them together. I mentioned this yesterday as well, just to share successes and challenges, but also to develop, it seems, enough momentum as a community to develop a strategic vision by the next IAU conference. And that's all I wanted to say. Thank you and congratulations on all the successes.
Oh, I thought you had a hand up.
No.
Oh,
It was.
are we all pointing at each other or somebody have a hand up?
Gareth.
Yeah.
Gareth would like to talk.
Say that there is a conference to do that. It's the Starlight Conference, where people are coming from around the world. Yeah, Connie, Ruskin are coming to it. So we already have that conference. So you're all invited once again. This is like stereo, John, you and I, the twins. So you're all invited. Exactly what we're talking about here. Come along and we'll map the future.
Tesney writes, there should be a resolution that light pollution is pollution and should be internationally recognized as such. Another actionable suggestion for us to consider in short time scale. We are at the end of our time and the business meeting is starting.
They
Thank
have a
you
really
all.
good result.
Yes.
We're going to hear about the resolution for satellite constellation. So
Thank you. You're welcome. And thank you to our expert crew in the back for making so much of this go so smoothly today.